अस्सलाम वालेकुम एवरीवन। क्या हाल है आप लोगों के? वालेकुम अस्सलाम, वालेकुम सलाम। आई एम गुड अल्हम्दुलिल्लाह। हाउ आर यू? वालेकुम अस्सलाम। It's on Reddit. Please don't tell me you guys are talking about some leaks. ऐसे ही है? I hope not. यार वो क्लैश द थिंग इज़ वी डिड कोऑर्डिनेट बट आई थिंक वो सर जैन की स्ट्रीम बिकॉज ऑफ इलेक्ट्रिसिटी इश्यूज थोड़ा देर से स्टार्ट हुई है, दैट्स वाई। वरना वी ऑलवेज कोऑर्डिनेट एंड वी कोऑर्डिनेटेड टुडे ऑल्सो, बट खैर हो गई। यू गाइज कैन वॉच हिज स्ट्रीम लाइव इफ़ यू वांट एंड यू कैन वॉच द रिकॉर्डिंग ऑफ दिस, सो अप टू यू गाइज। देर आर रूमर्स तो बेटा हर वक्त ही होते हैं, बस वो एज लॉन्ग एज रूमर्स की हद तक ही रहें तो ठीक है। इट्स नॉट माई बर्थडे। इट्स नॉट माई बर्थडे, ठीक है। माई बर्थडे, इन केस यू गाइस केयर, इज़ ऑन द 22nd of July, ठीक है। सर वर्क इक्वेशन ब्रीफली एक्सप्लेन कर देंगे। हर सिनारियो के साथ एप्लीकेशन चेंज हो जाती है? ऐसा नहीं है बेटा, एप्लीकेशन चेंज नहीं होती, इट रिमेन्स द सेम, सही है। सो बट आई विल एक्सप्लेन, ठीक है, डोंट वरी। ओके, सो लेट्स बिगिन this PDF you guys can download from the link in description. आज so अभी हो रहे हैं 5:46, so I'll try and cover as many questions as possible. Yeah, 22nd July is my birthday. Yep, that's correct. ठीक है, so let's try and solve as many questions as possible and let's keep our main focus on the work energy वाली जो equation है ना, the energy method. Let's keep our main focus on that. अच्छा, first I'd like to start with some easy questions and then we'll gradually increase the difficulty level. ठीक है, तो पहले ज़रा easy questions से start करते हैं, फिर we'll talk about फिर we'll look at some difficult questions also, and then if you guys want me to solve a specific question I'll try and include that also. ठीक है। अच्छा, by the way, today at 8 again I'm doing a stream on momentum because tomorrow you guys have your exam and tomorrow I want to basically I'm saving the syllabus run through for tomorrow, so tomorrow inshallah we'll have a syllabus run through जिसकी timings मैं inshallah आज रात में announce कर दूंगा, but tonight at 8 PM again we will have another stream covering momentum questions, okay, those difficult ones inshallah. Okay, so let's have a look at this question. This is question number 2 of your of this PDF, and what year is this from? This is from February-March 2020, paper 4 variant 2, ठीक है। Let's see what it says. So this question says, एग्ज़ाम वेंसडे है ना आपको? या सो आई मेंट tomorrow I'm basically going to do syllabus run through so that you guys, because you guys have your exams on Wednesday, ठीक है। अच्छा, my apologies guys। खैर, so let's start, let's not waste any more time. A lorry of mass 16,000 kg is traveling along a straight horizontal road. The engine of the lorry is working at a constant power. The work done by the driving force in 10 seconds. Okay. Now, why are we given the work done in 10 seconds and then the question is asking us to find the power of the lorry's engine? Acha, saath mein, let's just review the notes also. So notice that we have two formulas for calculating power. One is force into velocity. Force into velocity, if you use that formula, that gives you the power at a certain instant. Okay, I'll share these notes also with you guys in case you want them. I'll upload them in the same folder as the worksheet. So if you want to find out power at a certain instant, or if let's say velocity is constant, in that case the formula that you use to calculate power is force into velocity. But if you're given average power, okay, or if you're given work done in a certain time, in that case, the formula that you use to calculate power is work done upon time. ठीक है, जब भी average power का जिक्र हो, in that case, what we do is we use the formula work done over time. ठीक है, so let's go over some formulas. Yeah. So power equals to work done upon time. This formula is used when the object is accelerating velocity, when velocity is not constant, or when a time interval is given, or when asked to calculate average power. And then we have another formula of power, which is force into velocity. In the formula of power, F is always the driving force. This formula is used to find power at a certain instant or when velocity is constant. Okay. So a lot of times students get confused. Okay, when do we know or how do we know which formula to use? Well, this is basically how you distinguish. क्या बात है, आज कैमरे की पोजीशन थोड़ी आउट लग रही है. अब सही है. Okay. Now, so let's carry on. Question number 2, part A. So how will I calculate the power? Power is simply equal to work done upon time. Make sure to read the question carefully. Sometimes the question will give you the work done in kilojoules, or sometimes the question will ask you to calculate the power in kilowatt. So just watch out for that. None of that applies here, but just generally speaking. So 750,000 divided by 10, what's that equal to? That's equal to 75,000 watt. Okay, so one easy mark. All right, let's see what the question says next. There is a constant resistance force on the lorry acting on the lorry of magnitude 2400 Newton. Find the acceleration of the lorry at an instant when its speed is 25 meters per second. Okay, so if we're talking about the speed at a certain instant, so what is power equals to? Power this time is equals to force into velocity. Now the power we just worked out is 75,000. Why are we using this formula? Because it's talking about a certain instant. So 75,000 is equals to force. What is the force? The force is what we're supposed to find out. What is the velocity? The velocity is 25. So with the help of this, we can find out the force. And remember, the force is always the driving force that we have over here. So 75,000 divided by 25, what's that equal to? That's equal to 3,000 Newton. Okay, ये क्या है? ये driving force है. Okay. Now, what's the formula that we use to find out acceleration? It's F net equals to mass times acceleration. That means all the forces acting in the direction of motion minus all the forces acting in the opposite direction equals to mass times acceleration. So the only forward force is the driving force, which is 3,000. The force that's acting in the opposite direction is 2,400. This is equal to mass times acceleration. The mass of the car is 16,000 into acceleration. So this is equal to 600 divided by 16,000. What is that equal to? That's equal to 3 upon 80, or A is equals to 0.0375 meter per second square. That's it. So 1 plus 3, that's 4 easy marks. Okay. Now I deliberately started with some easy questions. Okay. Kilowatt, it doesn't say kilowatt over here. Okay. Let's do another 1 or 2 easy questions, then we'll gradually increase the difficulty level of the question. Okay. अच्छा, hence find the work done by the pushing force. ठीक है, इस तरह के questions में हम end में आते हैं. पहले let's just focus on questions where you have to use Newton's second law. Yeah, let's do this one. Okay, so in work energy power, you will find questions where you have to use Newton's second law, and you will find questions where you have to use the energy method. So I'm keeping the energy method questions for later. First, let's focus on as many questions as possible where we have to use Newton's second law. ठीक है. Okay, now this is a question from May-June 2020, paper 4, variant 3. Let's see what it says. So this question says, a minibus of mass 4,000 kg is traveling along a straight horizontal road. The resistance to motion is 900 Newton. Find the driving force when the acceleration of the minibus is 0.5 meter per second square. Okay, now F net is equals to mass times acceleration. What is F net equal to? F net is equals to forward minus backward equals to mass times acceleration. Because this is a straight horizontal road, we don't have to consider the weight component which is acting down the plane or stuff like that. Okay? Now, what's the forward force? The forward force is the driving force. What is the backward force? The only backward force that's mentioned in the question is the resistance to motion, which is 900 Newton. And what is this equal to? This is equal to mass times acceleration. And what is the acceleration? The acceleration is 0.5. That's given to us already. So 4,000 into 0.5 is 2,000. 2,000 plus 900, that's equal to 2,900 Newton. Okay. Find the power required to maintain a constant speed of 25 meters per second. So which formula are we going to use? We're going to use power equals to force into velocity. Why? Because we're given that the speed is constant. What's the driving force? Achha, wait a minute. The driving force, we'll have to figure it out. We can't use the previous one. Why? Because right now, it's not accelerating. Right now, the acceleration is equals to 0. If acceleration is equals to 0, that means the forward force is equal to the backward force. And what is the only backward force? The only backward force that we have in this question is the 900 Newton force. Okay? Now, what's next? Next is we have the force. We also have the velocity. We can find out the power. So power is equals to 900 into 25. That's equal to 22,500. Does it say kilowatt? No, it doesn't. So we'll leave it over here. Acha. But why are you so interested in movable pulleys, may I ask? ये पिछले 2-3 दिन से सबको अचानक movable pulleys में interest क्यों बढ़ गया? Has the syllabus changed overnight? Or is it because of something else? Can we write as 22.5 kilowatt? Yeah, you can do that. अब जो क्वेश्चन ने वैसे बोला नहीं है तो आप क्यों इतने ओवर एफिशिएंट हो रहे हैं बेटा? Sir, when A is 0, forward equals to, yep, that's correct. Okay, now, sir, आपको गुस्सा आ जाएगा अगर पता चलेगा. गुस्सा आ जाएगा मुझे. अच्छा, ऐसा क्या है? अच्छा, अब let's circle back to question number 1. ये सवाल करते हैं. इसमें we'll have to use, I think we'll have to use the energy method. देख लेते हैं. ठीक है, फिर कुछ recent questions भी करेंगे. थोड़ा mix and match करेंगे. Let's make the most of the time that we have. So this is question number 1 of the worksheet, which is from February-March 2020, paper 4, variant 2. ठीक है? Let's see what it says. So ये कह रहा है, the diagram shows the vertical cross section of a surface A, B and C are 3 points on the cross section. Okay. The level of B is h meters above the level of A. The level of C is 0.5 meters below the level of A. All right. A particle of mass 0.2 kg is projected up from the slope with initial speed of 5 meters per second. All right. The particle remains in contact with the surface as it travels from A to C. So the particle is traveling from here to here. Think of it as, क्या होता है? Skating, like a skating ring. Okay, now, given that the particle reaches B with a speed of 3 meters per second and there is no resistance force, find H. Okay. Now, the question does not say that you have to use the energy method, but we can use the energy method over here. Okay, we can use the energy method over here. Okay, वो कैसे? Total work done is equals to change in potential energy plus change in kinetic energy. Is there a driving force? No, there isn't. Is there a resistive force? No, there isn't. Okay, how do I know that? By reading the question, which I'm afraid a lot of you don't, sadly. Now, total work done means work done by any force that's acting in the direction of motion other than the weight. And against means work done against the direction of motion, work done against friction, which there isn't any. That means the total work done is equals to 0. Now, as far as the change in potential energy is concerned, there's going to be a gain in potential energy. And change in kinetic energy will just take care of itself, whether it's gain or loss, when we plug in the speeds correctly. Okay? So let's calculate the change in potential energy. The mass is 0.2. G is 10. The height that it gains is exactly what we are here to find out. Okay. Plus the change in kinetic energy. What's the change in kinetic energy? Half into 0.2 into final velocity squared or final speed squared minus the initial speed squared. Okay, so notice that this object started with a speed of 5 meters per second, and when it reached B, it was traveling at a speed of 3 meters per second. Okay, let's see what we get. So we get 0.2 into 10, that's 2. 2 into h, that's 2h. So 0 is equals to 2h. All right, let's work this out. 1 upon 2 into 0.2 into 3 squared minus 5 squared. This formula, if you really understand, if you really come to good terms with this formula, it's a game changer. So 2h minus 8 upon 5, okay, which means 2h is equals to 1.6, which means h is equals to 0.8. And that's it. Job done. Okay. Why is total work done 0? Because there is no work done, or there is no force that's acting in the direction of motion. Okay. And there is no force that's acting against the direction of motion. Okay. Total work done is basically the force that's acting in the direction of motion, which there isn't any. Acha, the screen was stuck, okay, but it's fine now, I guess. Yeah. And then against means the work done, which is against the direction of motion. That's it. Okay? That's what it means. And anyway, I think it was my internet, but I think it's fine now. Okay? Acha, let's do another question. This part also, for this also, we will use the energy method. Don't worry. It is given instead that there is a resistance force and that the particle does 3.1 joules of work against the resistance force as it travels from A to C. Find the speed of the particle when it reaches C. Okay. अच्छा, अब हम देख रहे हैं क्या? अब हम देख रहे हैं story को from A to C. Okay, so now we're looking at from A to C. Okay, now once again I am going to use the same energy method, which is total work done is equals to change in potential energy plus change in kinetic energy. Okay, and what still remains the same? The fact that the initial speed is 5 meters per second, that remains the same. Okay, so that means the initial speed is 5 meters per second. Okay, and what we're supposed to do is we're supposed to find out the final speed. Acha, if I'm looking at it from A to C, then we can see that there will be a loss in potential energy. Okay, why will there be a loss in potential energy? There will be a loss in potential energy because it starts from this point, and when it finishes, its height is decreased by 0.5 meters. Okay, now how will I calculate total work done? Total work done once again means by minus against. By means that work done by driving force or any force that's acting in the direction of motion, and there isn't any, so that is 0. But the work done against the resistance force is given to us, and that is 3.1. This is equal to change in potential energy, which is a loss. And what is that equal to? That's equal to 0.2 into 10 into 0.5. Okay, so this is the loss in potential energy. Now kinetic energy में हमें sign लगाने का मसला नहीं है because वो खुद ही it takes care of itself. So half into m, which means 0.2 into v squared, that's exactly what we're here to find out, minus u squared, which is 5 squared. Okay, now let's solve this. Let's see what we get. So we get minus 3.1 equals to 0.2 into 10 into 0.5, that's equal to minus 1 plus, let's work this out carefully, 0.2 divided by 2, that's 0.1, so plus 0.1 v square minus 1 upon 2 into 0.2 into 25 minus 5 upon 2. ठीक है, मैंने क्या working किया? I'll explain. So basically the working that I've done is this. What is 0.2 into 1 upon 2? That is 0.1. So 0.1 v squared minus 25. This is what I've done. 0.1 into v squared is 0.1 v squared. 0.1 into 25, that's 2.5. Okay, let's write it as 2.5 only. Since I've written one value in decimal, let's write the other in decimal also. So minus 2.5. Okay. Now, what do we have to do? We have to make v the subject. So let's take all the constants across the equals to sign. So minus 3.1 plus 1 plus 2.5, that's equal to 0.4. 0.1 v square is equals to 0.4, which means v square is equals to 0.4 divided by 0.1, which is equal to 4, which means v is equals to 2 meters per second. And that's it. Job done. Okay. Now a quick summary. Summary is, why don't we take 3? 3 for what? Why would I take 3? 3 to beta was only the case for part A. 3 was only the case for part A. Okay. Now, so I'll give a summary. So the question is such that now the particle starts at A and ends at C. Why is there a minus sign in potential energy? If a particle is going from A to C, what is the change in height? The change in height is 0.5. Now, is it a gain or is it a loss? It's a loss. So if an object loses height, it loses potential energy. That's why you see a minus sign. Okay, that's why I've written loss over here. Now, total work done equals to change in potential energy plus change in kinetic energy. Total work done basically means work done by the driving force or any other force that's acting in the direction of motion minus against, which means the work done by any force that's acting against the direction of motion or work done against friction. There is no driving force, so this is simply 0. But there is work done against the resistance force, and that is given to us in the question, which is 3.1. Now, what about the change in potential energy? The object is going from A to C. If it's going from A to C, you can see that it loses height of 0.5. That's why I put a minus sign over here. Or some people put minus sign with the height. That also works. Doesn't matter. Okay. As far as the change in kinetic energy is concerned, we're supposed to find out the final velocity. We have the initial velocity. So how will you calculate the change in velocity? You will do half m v square minus u square. Now, once you are able to form this equation, after that, it's all downhill. Why? Because all you have to do is expand, simplify, find out the value of v, and that's it. Yes, tomorrow, inshallah, I will do a full syllabus run through. Don't worry. Okay, let's do another question. इसमें कोई energy method involved है? I want to focus on energy method as much as possible. I think there is energy method involved over here. Okay, let's have a look. A block B of mass 4 kg is pushed up a line of greatest slope of a smooth plane inclined at 30 degrees to the horizontal by a force applied to B acting in the direction of motion of B. The block passes through the points P and Q with speeds 12 and 8 meter per second respectively. It's pushed up a line of greatest slope, smooth plane, by a force applied to B acting in the direction of motion of B. Okay. The block passes through points P and Q with speeds 12 and 8 respectively. Find the decrease in kinetic energy as it moves from P to Q. Now, as far as the first part is concerned, you don't really need to make a diagram. We'll do that for the following part. Okay, we'll do that for part B. In the first part, you can see that its initial velocity is 12 and its final velocity is 8 and the mass is 4. That's all you need to find out the decrease in kinetic energy. Okay, so you will do half into m into v square minus u square. Okay. Change in kinetic energy basically means half m, and as far as the velocity is concerned, final squared minus initial squared. So 1 upon 2 into 4 into, अच्छा इसमें आपने किस चीज़ का ख्याल रखना है? इसमें आपने इस चीज़ का ख्याल रखना है because the question is asking for decrease, you will not give it with the minus sign. So this turns out to be minus 160, but you should know that your answer is going to be 160 because the question is asking for decrease. ठीक हो गया? Okay, now let's see what's next. sir, is it better? Of course it's a good idea to make diagrams. ठीक है, better नहीं, you must. Hence find the work done by the pushing force. Okay, so here you will really see how the energy equation really helps. Work done by the pushing force, the block up the slope as the block moves from P to Q. ठीक है, तो यहाँ पे आपको सही कदर आएगी energy method की. So here we are. अच्छा यहाँ पे नहीं आएगी, नहीं यहाँ पे नहीं आएगी. आई एम अफ्रेड यहाँ पे नहीं आएगी. ठीक है, यहाँ देख लेते हैं. So this is the force. ऐसे ही है. The plane is smooth, so there is no friction. देख लेते हैं अभी. ठीक है, and the angle of inclination is 30 degrees. The angle of inclination is 30 degrees. ठीक है. अच्छा, what else is going on? Smooth plane, 30 degrees to the horizontal by a force applied to B, acting in the direction of motion of B. The block passes through the points P and Q with speed 12 and 15. अच्छा, एक काम करते हैं. Instead of drawing it like this, इसको एक circular object की तरह draw कर लेते हैं. So here's the force, which is B. Is that correct? Yeah. Now at this point, its velocity is 12. Okay, and this is the point P, and then later on it reaches another point which we're going to call Q, and at this point its velocity is 8. Yeah, it's 8 meters per second. Okay, now what distance does it move up the plane? Not mentioned. Yeah, not mentioned. Okay, but we can work it out. How? Here's how we can work it out. The height that it will gain, we can work that out by forming a simple triangle. Okay, so if this is 30 degrees, okay, the height that it will gain will be, अच्छा wait, 10 meters दिया हुआ है हमें. Okay, brilliant. So if you're given 10 meters, that means this will be equal to 10 sine 30. All right. Now here also, I'm going to use the energy method. So total work done is equals to change in potential energy plus the change in kinetic energy. Okay. Now we want the work done by the pushing force, okay, or by the driving force. What is work done against the direction of motion? There isn't any. Why? Because it's smooth. Now, as far as change in potential energy is concerned, it's going to be a gain in potential energy. And as far as the change in kinetic energy is concerned, we've already worked that out. That's equal to minus 160 joules. Okay, so I repeat. Total work done is equals to by minus against. Okay. This is equal to change in potential energy, and it's going to be a gain because it's going uphill, so its height will increase, and this is what the height will increase by. And as far as the change in kinetic energy is concerned, the change in kinetic energy is negative. Why negative? Because we just worked it out in the previous part that it's minus 160. Now, what is the work done by the pushing force? We don't know. What is the work done against motion? It's 0. Why 0? Because it's a smooth surface. Okay. What is the gain in potential energy? The gain in potential energy will be mgh. What is m? M is 4. What is acceleration due to gravity? That is 10. And what is the height? That's equal to 10 sine 30. What is the change in kinetic energy? It's minus 160. Okay. So here we have the work done by the driving force, and what's that equal to? 4 into 10 sine 30 minus 160, and that's equal to 40 joules. ठीक हो गया? Okay, now sir, there are some type of old questions where there are two different particles. Yeah, we'll do those also. We'll do those also. where you have two objects that are connected. Don't worry about that. We'll do those. Sir, important, can you do May, June 2023, paper 4, variant 3? Tell me what question number is it from this worksheet. Tell me what question number is it from this worksheet and I'll do it, inshallah. Okay. Wasn't there friction? No, because it's a smooth surface. I underlined that initially because it's a smooth surface, therefore no friction. Okay. Acha dekho, if you have memorized a different form of the energy method, then please stick to it. Acha wait, there's more. There's part C also. Let's complete part C. I didn't realize that this question had a part C. Part C says, this is question number 3. Question 3, part C says, at the instant the block reaches Q, the force pushing the block up is removed. Find the time taken after this instant for the block to return to P. Okay. So if there is no force which is pushing this block up the slope, that means it's no longer going to go up the slope. Okay. So this is point P. Don't forget the angle of inclination was 30 degrees. Okay, so this is, let's suppose, point P. This is point Q, which happen to be 10 meters apart. Now, as soon as this block reaches point P, okay, what happens is the force that was pushing this or pulling this up the slope is now removed. Okay. अच्छा वैसे I just realized कि because this was a pushing force, तो इसका जो arrow है ना वो हमने गलत लगाया. Although it's not a deal breaker, it's not change, it won't change the answer or anything, but because it's a pushing force, so you'll place it over here. Okay, makes no difference as to how we treat it, okay, as to how we use it in any equation, but just remember this is what a pushing force looks like. Okay, now there is no pushing force, okay, and what we have to do is we have to find out the time taken after this instant for the block to return to P. The question is, okay, what is the force due to which it's going to come down? There will be a force due to which it's going to come down, and that will be its own weight component. So this is 30 degrees. The force due to which it's going to come down. What is the weight of this object? It's 40 newtons. Yeah, since the mass is 4. So this will be 40 sine 30. Okay, and once again, since it's smooth, we don't have to worry about the normal reaction force, and consequently, we don't have to worry about the frictional force. So now we're going to do forward minus backward equals to mass times acceleration. What is the direction in which it's going to move in? This is going to move in this direction. Okay? This is the direction in which it's going to move in. Now, there is no forward force, okay, but there is a backward force. And what is that? या बल्कि एक काम करते हैं ना, let's treat it as acceleration. Okay? Why? Because since we're considering this direction to be the forward direction, so the forward force is 40 sine 30. Okay, and the backward force, there is no force acting opposite to the direction of motion, equals to mass times acceleration. That means equals to 4a. So 40 sine 30 means it's equal to 20. 20 equals to 4a. That means acceleration is equals to 5 meter per second square. So that means as it's coming down, its acceleration is equals to 5 meter per second square. The question is, okay, what was the velocity at point Q? The velocity at point Q was 8 meters per second. So when it reached this point, its velocity was 8 meters per second. Okay? Okay, now, what do we have to do now? We now have to find out how long will it take to reach this point. Okay, what do we have to do? We now have to find out how long will it take to reach this point. Okay, so that means S is equals to 10. Okay? And the initial velocity is equal to 8. Achha, मैं ये solve करूँ, and I want you guys to point out if there is something wrong. Okay? What we have to do is we have to find out the time, and what is the acceleration? The acceleration is equals to 5. Okay? So what equation can we use? We can use S is equals to ut plus half at square. S is equals to ut plus half at square. Okay. Acha, hold on. Okay, let me solve it, and then you guys can tell me what is it that I am doing wrong. Okay? You haven't covered all the topics expected. Will you cover? Nahi beta, I will not be covering I've covered all the topics. I did not cover all the remaining topics in today's stream, but I've covered them in the past. Okay, so I would appreciate if you stop wasting your time and you stop spamming and you prepare for the exam that you have tomorrow. Okay? Okay, now, so what is the distance? The distance is 10. Okay? What's the initial velocity is? That's 8 times t plus 1 upon 2 into 5 into t square. ठीक है? अच्छा, अब इसमें क्या प्रॉब्लम है? इसमें कुछ प्रॉब्लम है नहीं है? Why not v equals to u plus at? Yeah, why not v equals to u plus at? No, we can't use that. We can't use that. Why? Because if you're thinking it will reach p with the same velocity as 12, that's not possible. Why? Because pehle there was a force that was being applied. Okay? So this does not hold. Okay? However, that force was applied up until this object reached the point Q, and that is the instant when that force was removed. That means the initial velocity, that means the velocity at that point was equal to 8. Okay? So that's why we can't use that formula, v equals to u plus at. Okay? Achha, अब if I work this out, so notice what happens. If I work this out, so we have 10, which is equal to 8t plus 2.5t square. Now, if I take all the terms to the right-hand side, notice what happens. Now, let's solve this quadratic equation. मैं सिर्फ time बचाने के लिए I'm using the quadratic formula, but in the exam, make sure that you show your working. So we get t is equals to, so we get two values of t. Okay, and I'll show you what those values are. 0.9612, and we get t is equals to minus 4.16. And you know what? Let me tell you, this is wrong. Now, who can tell me what is wrong over here? I've done it wrong deliberately. Okay, I want you to tell me what is wrong over here. Yes, I can see that you guys are. नहीं, zero नहीं होगी. U zero नहीं होगी. नहीं, U zero नहीं होगी. देखो, listen. The object is moving in this direction. Correct? The object is moving in this direction. Okay? When the force was removed, नहीं, acceleration positive भी सही है. Acceleration positive भी सही है. ठीक है? But when the force was removed, okay? When the force was removed, okay? What is the direction in which the object was traveling in? It was traveling in this direction. Okay? When the force was removed, the object was traveling in this direction, which means the initial velocity that we will take will be minus 8 meters per second. Okay? The initial velocity that we will take will be minus 8 meters per second. ठीक है? एक तो इसका तरीका ये है. ठीक है? एक इसका तरीका ये है कि आप initial velocity को instead of taking it as positive 8, you take it as minus 8. Okay, instead of taking it as positive 8, you take it as minus 8. You then solve, you will get the correct answer. Okay, and then I'll show you another method also. So S is 10. Okay, this is equal to minus 8t plus 1 upon 2 into 5 into t square. Okay, so now when you solve this, you get 2.5t square minus 8t minus 10 equals to 0. And when you solve this, you get the correct answer. Okay, now this is one way. 2.5 minus 8 minus 10, this gives you the correct value of t. T is equals to 4.16. And the other value of t that you get is minus 0.961, which is incorrect. Okay, so t is equals to 4.16 seconds. ठीक है? अच्छा, अब इसका alternate तरीका भी देख लो. Here is the alternative method. ठीक है? अगर अभी किसी को confusion है, so hold on to it. अभी clear हो जाएगी. ठीक है? So notice that as soon as the force is removed, it's not that the object will immediately start traveling in the opposite direction. Correct? As soon as you remove the pushing force, do you think the object will immediately start traveling in the opposite direction? No. It will still continue to travel in this direction. okay, it will still continue to travel in this direction. Okay, now I know what you guys are saying. Those of you are saying okay, we should take s as minus 10. Okay, you guys will understand why we take it as minus 10. Okay, and this is the method where we take it as minus 10, so just pay attention. So please understand, as soon as you remove the force that was pushing this particle up the plane, it's not as if the particle will immediately start traveling in the opposite direction. No, it will still continue to go up, and then it will start traveling in the opposite direction. Okay? So I repeat, as soon as you remove the force, the pushing force, it's not that the object will start traveling in the opposite direction immediately. It will continue to go up, and then it will start traveling in the opposite direction. Okay? And at this point, what is the velocity equal to? The velocity is equal to 8 meters per second. Why is u equals to 8? Guys, read the question. Read the question. Those of you are asking why is u equals to 8, this is the reason why u equals to 8. Okay? So a block of B of mass 4 kg is pushed up a line of greatest slope of a smooth plane inclined at 30 degrees to the horizontal by a force applied to B acting in the direction of motion B. The block passes through points P and Q with speeds 12 and 8. So when it reaches point Q, it is traveling at a speed of 8 meters per second. Correct? Now let's read this part. At the instant the block reaches Q, the force pushing the block up the slope is removed. So that means when the block reaches Q, what is the speed at which it's traveling? The speed at which it's traveling is equals to 8 meters per second. Okay? So here we are. As soon as the block reaches Q, what is the speed at which it's traveling? The speed at which it's traveling is 8 meters per second. Okay? Now, as soon as the pushing force is removed, the block will continue to go up. It's not that the block will immediately start coming down. Okay? So the question is, what is the force that's making this object go up? There is no force. There is no driving force. But what about the force that's acting in the opposite direction? That's going to be 40 sine 30. The force that's acting, वैसे this is the method that this is a much better method. पुराने वाले method में ना ज़रा थोड़ी सी confusion है. So you know what? Let's stick to the method that I'm using now only. Okay. So I repeat. As soon as the pushing force is removed, the block will not instantly start traveling in the opposite direction. It will continue to go up, but there will be no force that is going to make it go up. Okay, it will continue to go up because of the velocity. So forward minus backward equals to mass times acceleration. Now there is no forward force, but what about the backward force? The backward force is 40 sine 30, and the backward force is basically what will cause it to decelerate. And what's this equal to? This is equal to 4a. Okay? So what's a equal to? A is equals to minus 5 meter per second square. Okay? Ab dekho, understand this minus 5 meter per second square. This means that as the block is going up, it will decelerate at a rate of 5 meter per second square, and then it will start going down. Okay? And then it will start going down. Ab mujhe ye batao, okay, the block is moving in this direction and its initial velocity is equals to 8. If I want this block to reach point P, which is 10 meters in the opposite direction, what will be its displacement? So the initial velocity is 8 meters per second. The acceleration is minus 5 meter per second square. We want to find out the time. Okay, the question is, what will be the displacement considering that the block is moving up the plane and we want it to reach a point which is 10 meters in the opposite direction of motion? It's going to be negative. Okay, so the displacement will be negative 10. ठीक है, negative 10 please समझ लो, negative 10 क्यों है? Negative 10, why? Because we want it to travel 10 meter in the opposite direction. That is why it's negative 10. अच्छा, अभी मैं देख रहा था इसको कोई कह रहा था कि इसको आप इस तरह से कर लें कि we first find out the time that it takes to come to rest while it's going up, and then you work it out the time that it takes to come back down. We can do that, but for 4 marks, doing so much working does not make sense. Okay? So I repeat, why is displacement negative? Why? That's because the object, when it reaches P, has traveled 10 meters in the opposite direction of motion. So which equation can we use? We can use S is equals to ut plus half at square. What is S? S is minus 10. What is u? That's 8. 8 times t plus 1 upon 2 into the acceleration, which is minus 5 into t squared. Let's see what we get. We get minus 10 equals to 8t minus 2.5 t squared. तो वही चीज़ बन गई. you have 2.5 t square minus 8t minus 10. You get the exact same equation as before. And when you solve this, please make sure you either do, you can't do middle term breaking over here, so make sure that you show your working of the quadratic formula. Okay, please don't just use your calculator and write the answer directly. You will get penalized. You don't want to lose marks for something that you know how to do. So minus 8 squared minus 4 into 2.5 into minus 10 divided by 2a, that means divided by 2 times 2.5. Okay, once you write this down, then you can use your calculator to write down the final answer. So one value of t is 4.1612. The other value of t is equals to minus 0.9612. Now, obviously, we're talking about time. So the only value that makes the most sense is the positive one. There you go. Okay. That's it. Somebody said to do question number 5. Okay. Now let's do some questions where we have one object that's towing another object. Okay, and then we will do some recent questions. A car of mass 1800 kg is towing a trailer of mass 400 kg along a straight horizontal road. The car and trailer are connected by a light, rigid tow bar. The car is accelerating at 1.5 meter per second square. There are constant resistance forces of 250 Newton and on the car and 100 Newton on the trailer. ठीक हो गया. मोमेंटम की लाइव स्ट्रीम बिल्कुल होगी इंशाल्लाह आज 8 o'clock, if not 8 o'clock then 8:30. ठीक है. Find the tension in the tow bar. All right, let's find out the tension in the tow bar. Now, always a good idea to make a rough sketch. So you have a car, ठीक है, and then you have a trailer. They're connected, ठीक है. So this is the car, this is the trailer. The car is accelerating at 1.5 meter per second square. So please, if the car is accelerating, what about the trailer? There was a confusion yesterday. If the car is accelerating, oh yeah, it's horizontal. It is horizontal. Whoops. If the car is accelerating, what happens to the trailer? The trailer is also accelerating. ठीक हो गया? Even if, let's say, the resistance forces are different, they're both accelerating. ठीक है? Now, find the tension in the tow bar. So let's look at from the trailer's perspective. Okay, let's look at the forces from the trailer's perspective only, since we're supposed to find out the tension in the tow bar. So if I look at the forces from the trailer's perspective, there is tension, okay, due to which it's moving forward. And as far as the trailer is concerned, on the trailer, there is a 100 Newton force which is acting in the opposite direction. Okay, so that means T minus 100. Obviously, the acceleration will be the same, okay, equals to mass times acceleration. So that's 400 into 1.5. 400 into 1.5 is 600. 600 plus 100, that's equal to 700. And I don't understand why you're given so much space, but chalo. Not bad. Okay, find the power of the engine of the car at the instant when the speed is 20 meters per second. Now, before we can find out the power, we need to find out the driving force. Okay, so before we can find out the power, because power equals to force into velocity, and the question is, okay, how will we find out what is the driving force? Okay, so what is the driving force? Okay, now let's look at the forces from the car's perspective. From the car's perspective, obviously if it's accelerating, that means there is a driving force, okay, and tension is acting in the opposite direction, and there is a resistance to motion on the car also, which I believe is 250. Yeah, 250. So if I look at the forces from the car's perspective, it's dF, driving force, minus 250 minus the tension, which we just worked out as 700, is equals to mass of the car, which is 1800, times the acceleration, which is 1.5. Now let's work this out. The driving force of the car is equals to 1800 into 1.5 plus 250 plus 700, and that's equal to 3650. Now, because you want to find out the power at a certain instant, we can use the formula 3650 multiplied by the speed, which is 20. So power is equals to this multiplied by 20. That's equal to 73,000. 73,000 watt. Is there another part? No, there isn't. Okay. All right. Now, S1 inshallah, जैसे आप लोगों का P1 का एग्जाम हो जाए, then we'll start S1. Driving force of car only, right, sir? So we won't consider tension. You will consider tension, but tension is acting in the opposite direction. Yes, of course, tension will be equal because they're connected by a single tow bar. Okay, so I repeat. See, this is the system. The car and the trailer, they're both accelerating. Okay, if the car is accelerating, obviously the trailer is also accelerating. Now the question is, what is the reason due to which the car is accelerating? Because there is a driving force. Okay, now if I look at the forces from the car's perspective, there is driving force which is acting in the direction of motion. There is 250 Newton which is acting in the opposite direction. That's why we subtract. And there's also tension acting in the opposite direction. And because this is one single tow bar, just like in pulley related questions, if you just have one string, tension throughout the string will remain the same. Okay, so just because we have one single tow bar, that is why the tension in the tow bar is the same. Okay, and what is that tension? That tension is equals to 700. So driving force minus the resistive force minus tension equals to mass times acceleration. This gives us the driving force of the car. And what is that equal to? That's 3650. And since we want to find out power equals to force into velocity. What's the driving force? 3650 multiplied by the velocity, which is 20. And there you go. That's your answer. अच्छा, और सवाल करते हैं where we might have to use energy method. Did we do this question yesterday? Yeah, let's do some recent questions. Some October-November related questions करते हैं. अच्छा, ये तो momentum आ गया. S1 बेटा, I will start as soon as you guys are done with M1. ठीक है, so 6th से मैं इंशाल्लाह S1 भी start करा दूँगा. Okay, let's do this. Yeah, P3, S1, both of them, inshallah, starting from the 6th. Let's have a look at question number 56, guys. Okay? Let's see what question 56 is. 56, by the way, is October-November. Okay? 2025, paper 4, variant 5, it's the Chinese variant. Okay? Now, let's see क्या बोल रहे हैं. So it says a car of mass 800 kg is moving on a straight road. All right. When a car is moving at a constant speed of 20 meters per second on a horizontal section of the road, the engine of the car is working at PW. All right. When the car is moving at a constant speed of 12 meters per second up a section of the road inclined at sine inverse of 0.15 to the horizontal, the engine of the car is also working at PW. Okay, so that means power in both cases remains the same. However, what will change is the driving force. Okay? Okay, now, on both sections of the road, there is a constant force of magnitude R Newton resisting the motion of the car. Find the value of R and the value of P. ठीक हो गया? Okay, so first we have a horizontal road, then we have a inclined road. ठीक है, तो पहले हमारे पास एक हॉरिजॉन्टल रोड वाला सेक्शन है, देन वी हैव एन इंक्लाइंड रोड. ठीक है, तो चलें इसको सॉल्व करते हैं. S1 मॉक भी बेटा इंशाल्लाह आई विल स्टार्ट एज सून एज वी आर डन विथ M1. ठीक है, okay, now let's start. How much space do we have? Plenty of space. Okay, so first let's look at the horizontal part of the road. Okay, so here's your car and the driving force, we'll have to work that out. power is equals to force into velocity. The power is P, the driving force we don't know, but we know that the velocity is equals to 20, so force is equals to P upon 20. Okay, now what about the resistance to motion? Here is the resistance to motion. Okay, and the resistance to motion is R. Yeah, on both sections there is a constant force of magnitude resisting the motion, and that is R. So let's make double arrows to show the direction in which the object is moving in. Here we go. Okay, so this means that if I use the formula forward minus backward equals to mass times acceleration. Is the acceleration 0? Yeah, it is 0. Why? Because it's moving at a constant speed. In both cases, it's moving at a constant speed. Okay, in fact, that's the reason why we're using this formula of power. So P upon 20 minus the backward force, which is R, equals to mass times acceleration, which is equal to 0. So there's not much we can do except that we can make maybe P the subject if you want. Okay, so P upon 20 is equals to R, and let's keep it as it is. Okay, let's keep it as it is. Or maybe जब यहाँ तक पहुँच ही गए हैं, so let's make P the subject. So P is equals to 20 R. Looks nicer that way. So here's the first equation. ठीक हो गया? I have a question in question 5. Why did you not take 100 Newton as backward force? In question 5, 100 Newton as backward force. Okay, पहले ज़रा मैं ये आंसर कर दूँ. Question number 5 कौन सा था? 3, 4, 5. Because I was only looking at the forces from the car's perspective. Okay, I was only looking at the forces from the car's perspective. That is why. Okay, just like when you are resolving, when you pick an object, okay, in pulley related questions, when you pick an object and you resolve forces with respect to that object, you only look at the forces acting away, or you only look at the forces acting at that point. That's why. Okay. Achha, what else? Why did I not take friction? Because whenever you're given the constant resistance to motion, friction and all the other forces that you have are included here. Okay. All the forces, whether it's frictional force, air resistance, whatever form of resistance there is included. Okay. So you don't have to consider frictional force separately. Okay. Now let's look at the second scenario when the car is moving at a constant speed, but this time it's moving up a section of the road which is inclined at an angle of sine inverse 0.15. Okay, so if theta is equals to sine inverse of 0.15, this means that sine theta is equals to 0.15, but this is something we'll come back to it later on. Okay, okay, now let's look at the forces from, once again, the forces from the car's perspective. So this time there is a driving force. Okay, the driving force will be different, but as far as the resistive, as far as the forces acting in the opposite direction, got to be careful about that. So power once again is equals to force into velocity. The power remains unchanged. The driving force we don't know, but as far as the velocity is concerned, what is the velocity? The velocity is 12. Okay, so that means this time the driving force is equals to P upon 12. Okay, this time the driving force which is making the car move up is P upon 12. Okay, so the car is moving in this direction. The force due to which it's moving up the plane is P upon 12. Okay, make sure that you are 100% invested into this question. You're aware of all the forces that are acting, the direction in which the object is moving in, and all the resistance, all the forces resisting motion. And that in this question is also equal to R. Okay, except that in this scenario, because it's an inclined plane, there is another force which is acting in the direction opposite to the direction of motion, and that is the weight component of the car, and that will be 8,000 sine theta. So since the weight is 8,000, so that means the component of the weight which is acting in the opposite direction will be 8,000 sine theta. How much space do we have? Not a lot, so let's be careful. So once again, we're going to use the formula forward minus backward equals to mass times acceleration, which is basically Newton's second law. Now this time the forward force is P upon 12. The resistive force is R and 8,000 sine theta. And this is equal to what? This is equal to mass times acceleration, which is equal to 0. Okay? Now, notice that we have already made what? We have already made P the subject. Correct? We've already made P the subject. So before I plug it in, let's write this nicely. P upon 12 minus R minus 8,000 into 0.15. What's that equal to? That's equal to 1200 equals to 0. Okay, now it's time to plug in P as 20R. So we have 20R upon 12 minus R is equals to 1200. Okay, so what's 20 upon 12? That's whatever. Minus 1, that's equal to 2 upon 3. So this turns out to be 2 upon 3R, which is equal to 1200, which means if I find out the value of R, for which I'm going to do 1200 into 3 divided by 2, that's equal to 1800. So we've worked out the value of R. What does the question say? Find the value of R. So we've done that. Now let's find out the value of P, which is pretty simple considering that P is equals to 20R. So 20 times 1800, that's going to be 36,000. So the power is equals to 36,000 watt. ठीक है? मजा आया? All right, let me see what's going on here. So aren't the two values of P different? Nope, they're not. The two values of F are going to be different, but the two values of P are not going to be different. Why? Because read the question. The question says, आप लोग सवाल क्यों नहीं पढ़ते? You know, half my job is teaching, the other half is actually reading the question. So the engine of the car is working at PW. The engine of the car is also working at PW. So that's why P is the same. Okay, I'll give you guys a summary. So basically, it's the same car with the same power and two different scenarios to consider. Okay? So one is where it's traveling on a horizontal road. Okay? And in that case, the power is P, the velocity at which it's traveling is 20, so the driving force is P upon 20. Okay? The constant resistance to motion is R, so we use Newton's second law, forward minus backward equals to mass times acceleration equals to 0. Why is mass times x, why is acceleration 0? That's because the car is traveling at the constant speed. And how do I know that the car is traveling at the constant speed? By doing something you guys barely do, and that is reading the question. Okay. Now, so we have one equation, which we're going to park, and we're going to come back to it later. Now let's look at the scenario when the car is moving up a hill. And that hill is inclined at an angle of sine inverse 0.15. So sine theta is equals to 0.15. This time, the driving force is different because it's moving at a different velocity. The power, however, is the same. So driving force equals to P upon 12. That's the forward force. The backward force is still R, and the backward force is also its own weight component, which is 8,000 sine theta. Okay? So P upon 12 minus R minus 8,000 sine theta is equals to 0. This is another equation. We already have made P the subject in terms of R. Solve this equation simultaneously with this equation, and that's it. Answer aa jayega. ठीक है? Sir ji, don't you get tired सुबह से? No, I don't. This is what I do for a living. So yeah. Sir, so you think M1 is easier than P1? No, I don't think M1 is easier than P1. I think M1 is definitely more complicated than P1. But it depends on your appetite. If you have an appetite for questions like these, you'll find M1 easier. Yeah, of course, in two connected bodies, you can use energy method for two separate particles. एक सेकेंड ना. Okay. There is ECF everywhere. Okay. Simultaneous में do we show steps? बेटा इसमें ऐसे कौन से खतरनाक steps हैं जो आपको दिखाते हुए डर लग रहा है? एक ही तो step है आपका P equals to 20 आ रहा है, वो आपने इधर plug in कर देना है. तो इसमें ऐसे कौन से कोई scary steps हैं? Alright, part B. Find the acceleration of the car when it's moving at a speed 10 meters per second up the inclined section of the road with the engine working at 32 kilowatt. All right. So let's see what we can do. So it's moving. Achha, this is the power. This is the speed. So immediately what we can do is we can find out the driving force. Okay, since it's talking about velocity at a certain instant, this is the equation which fits perfectly. 32,000 is equals to the driving force, okay, multiplied by 10, which means the driving force is equals to 3,200 Newton. So here's the car, okay. The force due to which it's moving up is 3,200. Okay, so make double arrows to show the direction of motion always. And what are all the forces acting in the opposite direction? There is R, which we just worked out as 36. No, that was the power. 1,800. And then its own weight component, which will be what, 8,000 sine theta? Yeah, 8,000 sine theta. And that's it. So you have forward minus backward equals mass times acceleration. The only forward force is the driving force, which is 3,200. The backward force is 1,800. And then the backward force is also its own weight component, which is 8,000 sine theta. Might as well work it out. 8,000 into 0.15, that's equal to 1,200. So minus 1,200 is equal to mass times acceleration. The car has mass 800, so 800A. So 3,200 minus 1,800 minus 1,200, that's equal to 200. So 200 is equals to 800A, which means A is equals to 1.4 or 0.25 meter per second square. That's it. ठीक है. अच्छा 10 मिनट हैं until maghrib. एक सवाल और करते हैं. I'd like to do one with energy method. Okay, this is a question with energy method. ये करते हैं. So how do I know we have to use the energy method? See, if you're given, let's say, if it's accelerating, you're not going to use the energy method. Okay, if it's dealing with acceleration, you have to use Newton's second law. वैसे by using common sense is a good reply. But जहाँ पे acceleration का जिक्र हो रहा है ना, you're not going to use the energy method. Okay? But if let's say you're given the velocity at a certain point, then you're given the velocity at another point, or maybe velocity at two instants, that is when you use the energy method. Okay? Even if the object is traveling at a constant speed, you don't have to use the energy method. So you can still use the energy method. I don't see why not. You can say change in kinetic energy is equals to 0. Okay, you can still use the energy method. Okay, now let's do this question. A car of mass 1400 kg is traveling on a straight horizontal road, accelerates uniformly from a speed of 15 to 20 over a speed of 175. Find the time taken to travel 175 meters. Okay, so what can we do? What formula can we use? We can use the formula 2as equals to v square minus u square, or s is equals to ut plus half at square. नहीं, acceleration भी नहीं हमें थी. वैसे एक third formula है which you guys can use because the acceleration is constant. ठीक है, and that formula is this: s is equals to 1.2 into u plus v times t. Yeah, that's the formula that we can use. Let me think, any other formula that you can use? कर तो सकते हैं लेकिन लंबी हो जाएगी. पहले आप acceleration निकालो, फिर आप निकालो time. लंबी हो जाएगी. Might as well use this. ठीक है, but if it doesn't occur to you, then please note that there is always a plan B. Okay, if it doesn't occur to you that this is the formula that you have to use, then please don't shy away from going the extra mile. So 2as equals to v square minus u square. Okay, you're given enough space to actually use the longer method also. So 2 times a into 175 equals to 20 squared minus 15 squared. This will give you the acceleration. So that's 20 squared minus 15 squared divided by 2 divided by 175. The acceleration is 0.5. And then you can use v is equals to u plus at to work this out, to work out the time. So 20 is equals to 15 plus 0.5 times t. So 20 minus 15 divided by 0.5, so t is equals to 10. Okay. But if it does occur to you that there is a shortcut, use the shortcut. 175 equals to 1 upon 2 into u plus v times t. That's 15 plus 20 times t. So let's say you will get the answer directly, which is equal to 10 seconds. So guys, just give me 2 minutes. I would like you guys to attempt part B. ठीक है, मुझे 2 मिनट दें. I'll be back on my desk. Okay. Let's solve. अच्छा, in the meantime मैं देख लूँ आप लोगों के आंसर क्या आ रहे हैं. Two 26250 is correct. 26250 is correct. So इसको जल्दी से solve कर लेते हैं, फिर we'll take a namaज break. Okay. So first of all, notice that the speed is changing. That is one hint towards using the energy method, and the fact that the question says explicitly. Now, what is the energy method? That is total work done is equals to change in potential energy plus the change in kinetic energy. Okay? Okay, now, as far as the total work done is concerned, is there a resistance to motion? Yes, there is. So what is the work done by the driving force? That is what we're supposed to find out. What about the work done against? We can work that out. We'll work that out. And change in potential energy is 0. Why? Because it's traveling on a straight horizontal road. And then as far as change in kinetic energy is concerned, we will work that out. ठीक है, तो इसको अगली लाइन से वर्किंग शुरू करते हैं. So the work done by the driving force is what we want to calculate. To find out the work done against resistance to motion, we will take the work done, we will take the force of 800 and multiply it by 175. Then the change in potential energy is equals to 0. Why? Because it's traveling on a horizontal road. ठीक है. What about the change in kinetic energy? The change in kinetic energy will be half into m, which is 1400, into v squared, which is 20 squared, minus u squared, which is 15 squared. So with the help of this, we can calculate work done by the driving force. Okay. So it's 0.5 into 1400 into 20 squared minus 15 squared. ठीक है. Plus 800 into 175. So we get the work done by the driving force is 262,500 joules. Okay. Please understand that this is the work done by the driving force. Now, what is power equal to? Power is equals to force into velocity, but we can't use that because the velocity is not constant. But another formula of power that we have, which is the one that's going to fit here, is work done upon time. What is the work done? The work done is 262,500 divided by the time, which is equal to what? Which is equal to 10 seconds. We worked it out previously. That gives us the power. That is 26250. 26250 watt. All right, part 2. Find the steady speed that the car could maintain on a horizontal road if the engine is working at the power found in P part 1. Okay, so steady speed means what will be the driving force? Power is equals to force into, no need to write down the formula again and again. Steady speed means that we can use the formula power equals to force into velocity. Okay, let's not give it any, let's not waste a line writing down just the formula. If the power is constant, the question is, okay, what is the driving force going to be? We don't know. We know that the driving force will be equal to 26250 upon V. Steady speed means that the acceleration is equals to 0, and do not forget that the resistance to motion stays as it is. So this means that 26250 upon V minus 800 equals to mass times acceleration, which is equal to 0. So isko main directly kar raha hu, since we're not given a lot of space. What you will do is you will simply do 26250, something that we just worked out, and divide by 800, and that gives us the value of V as 32.8125, which you should not round off because it's the final answer, because it's the exact answer. Okay, so there we go. Why 800 into 175? How will you find out the work done? Work done is force into distance. The resistance force is 800. What is the distance that it moves? It moves 175. So what would be the work done as it travels this distance? Force into distance. Dekho, you can always use, there is a chance that you can use Newton's second law over here because we worked out the acceleration. So yeah, you can do that. But if the question says use the energy method, so beta, don't be rebellious. Okay? This is not art. This is math. If the question says do things a certain way, then you better do it the exact same way. Quick summary. Okay, I'll give you guys a quick summary. So the car is moving from one point to another, and the speed goes from 15 to 20, and we have to use the energy method. So what's the energy method? Total work done equals to change in potential energy plus change in kinetic energy. What is total work done? Total work done is by minus against. By means work done by the driving force or any force acting in the direction of motion, and against means that work done against the direction of motion, work done by any force that's acting against the direction of motion. What is the driving force? We don't know. What's the work done by the driving force? We don't know. That's exactly what we're supposed to find out so that we can find out the average power. Now, what is the work done against motion? The question is, how do you calculate the work done against resistance? For that, what is the resistance force? That's 800. What is the distance the car moves? It moves 175. Okay. Now, as it moves 175 meters, this will be the work done against motion. This is equal to change in potential energy, which is 0, as it's a horizontal road, plus change in kinetic energy. Why? Because the speed goes from 15 to 20. Solve this, you will have the work done by the driving force. Now, since you have the work done by the driving force, can you find out the power? Yes, power equals to work done upon time. Why are we using this formula? Because the speed is not constant, and we want the average power. And then in part 2, use Newton's second law. Because the speed is steady, that means acceleration is equals to 0, and this is what you will end up with. Okay, yes, you can write down the simplified version of it, okay, as in simplified fraction version, but do not round it off. Why? Because it's the exact answer. That is why you don't round it off. No, you do not take the work done against weight. You do not take the component of the weight. Okay. Why? Because वो आपका potential energy में include हो जाता है. अच्छा ज़ुहैर, आप काफ़ी टाइम से एक क्वेश्चन बोल रहे हो. मैंने आपसे कहा था कि tell me the question number from this worksheet, which you still haven't. तो बेटा tell me the question number from this worksheet so that I can solve. ठीक है. अच्छा अब लेते हैं break. Say we'll continue after break. No, you're not allowed to write in columns. You're only allowed to, you were allowed to write in columns back in O levels and IGCSE, not anymore. But we're not rounding off because this is the exact value. It's a terminating decimal. That's why we don't round it off. I don't teach us to. I don't teach us to. देखो अगर terminating decimal है ना, terminating decimal का मतलब क्या है कि decimal एक point पे आके रुक गया. That means it's the exact value. See this, let me see what my camera looks like. Yeah. So ये जो आप देख रहे हो, this is the exact value. ये रुक गया ना एक point पे. That's it. That means this is the answer. Okay. But अगर ये ऐसा होता है, जैसे for example, let's suppose sine 31 times 45. This is not an exact value. This is the kind of value that we round off. Okay, let's take a Namaz break, then we'll continue. Okay. Okay guys, welcome back. When are you doing IGCSE P4 syllabus run through? But I'm not doing IGCSE P4 syllabus run through. That's why I did a stream covering all the important topics that haven't been tested, and that's it. Okay. So it's not from this worksheet. I guess I found 2 questions from question paper. I was really solving. One is totally about work in energy power and the other is connected to energy method. चलो ठीक है, मैं फिर I'll include it. Wait. ठीक है, मैं सॉल्व कर लेता हूँ, टेंशन की बात नहीं है. कहाँ गया वैसे? Where did you send it? अच्छा guys, tell me, do you guys have an exam tomorrow? Do you have an exam tomorrow? Because I'm thinking कि मैं momentum की stream भी कल पे shift करके और फिर कल ही stream के बाद we do a syllabus run through. I'm just thinking. I haven't decided yet. Okay, this is a good question. Let's solve this. ये इसमें नहीं है, ऐसा कैसे हो सकता है? इस वर्कशीट में नहीं है ये सवाल. You're right. नहीं. Okay. Bio P3 tomorrow. Okay, and what time do you guys get done? What time do you guys get done with the exam? P3 is what? P3 is ATP, right? ATP तो जल्दी फारिग हो जाता है नहीं? नहीं, wait, ये तो A levels है. Sorry, forgot I'm teaching A levels. P3 is practical, right? So ये कैसा आइडिया है कि कल हम मोमेंटम करके उसके बाद हम वो कर लें. We do a syllabus run through. That way I will be able to do more of what we are doing because momentum is scheduled for 8 p.m. 8 p.m. and I don't think we'll be able to solve enough energy questions. Is frustum formula of part of O-level math syllabus? Like, can I use it and get full marks? Beta, frustum formula, avoid karo. It's not part of the syllabus. Just do it the normal way. Okay? Now, I've answered that question. Would appreciate if you stop spamming now. Okay, so question number 7. The diagram shows the vertical cross-section XYZ of a rough slide. The section YZ is a straight line of length 2 meters, inclined at an angle of alpha to the horizontal, where sine alpha is equals to 0.28. The section YZ is tangential to the curve at X, Y, and Y. Okay. That means if you draw a tangent at Y, this is what you're going to get. Okay. And X is 1.8 meters above the level of Y. All right. A child of mass 25 kg slides down the slide starting from rest. The work done by the child against the resistance of motion moving from X to Y is 50 joules. Find the speed of the child at Y. अच्छा, यहाँ पे, although it's not mentioned that we have to use the energy method, but we can still use the energy method. Okay. And bear in mind that the slide is a rough slide. That is why we're given the work done against the resistance force. Okay, so you don't have to worry about friction. At least not for X. Yeah, you don't have to worry about friction, at least as far as the motion from X to Y is considered. So total work done is equals to change in potential energy plus the change in kinetic energy. Now, as far as the total work done is concerned, this means by minus against. By means total work done by any form of driving force, any force that's acting in the direction of motion, other than the weight component, because the weight, work done by weight, is considered potential energy. Okay? So there is no force, there is no driving force. However, the work done against resistance to motion is 50 joules. So we'll consider that. That's minus 50. Now, as far as the change in potential energy is concerned, it's going to be a loss in potential energy because as the child goes from X to Y, the height decreases by 1.8. The mass of the child is 25, the acceleration due to gravity g is 10, and the height is 1.8. Now the child, I believe, starts from rest. Yeah, starting from rest. So what will be the change in kinetic energy? The change in kinetic energy will be half into m, which is 25 once again, into v square minus u square. V square means, we don't know. U square basically means the square of the initial velocity, which is equal to 0. And that's it. इसको solve कर लो, answer आ जाएगा. ठीक है? So let's work this out. So this is minus 50 is equals to 25 times 10 times 1.8. What's that equal to? That's equal to minus 450. Plus 25 upon 2 is 12.5 v square. So you have 12.5 v square is equals to minus 50 plus 450, which is 400. V square is equals to 400 divided by 12.5. And now when we take the square root of it, v square is equals to 32, by the way. V is equals to 4 under root 2. Okay, so if you really embrace the energy method, it's going to solve a lot of your problems. If you really embrace this total work done equation, it's going to solve a lot of your problems. Okay, S1 stream हम करेंगे next M1 के बाद, starting from the 6th. Okay, so just stay tuned. I'll announce on my Instagram. I've sort of made a tentative plan for S1. I'll announce it formally, inshallah, on the 6th. Okay, now, so while a fraction like 2 upon 3 is technically an exact number, marking scheme strongly prefer answer as decimals. No, where did you read that the marking scheme strongly prefers answer as decimals? ये आपने कहाँ पढ़ लिया? अगर कोई चीज़ fraction form में, then it's best to leave it as fraction form, because 2 upon 3, when you write it in decimal, you're supposed to write it with a recurring decimal, which sometimes you might forget. So you'll end up getting it wrong. Now, I do agree that there will be some leniency, but don't count on it. Okay? No, I do not teach S2, guys. I do not teach S2. Okay, so a quick summary. As the child is moving from here to here, we can see that it's losing potential energy, the child is gaining kinetic energy, and we can also see that there is work done against the resistance force, which means this is all pointing towards the energy method. So what's the energy method? Total work done equals to change in potential energy plus change in kinetic energy. Total work done basically means by minus against. By means that the work done by any form of driving force, any form of external driving force. Weight component is not an external driving force, okay? And there isn't any. Work done against resistance to motion, yes there is, that's 50 joules given in the question. Change in potential energy, there is, because from x to y the height decreases to 1.5, which is why you see a minus sign. Change in kinetic energy, obviously if the child is starting from rest and we're supposed to find out the velocity at y, so there will be a change in kinetic energy. Okay, do we only use work done by driving force? Yep, that is correct. It's not that we ignore weight components, it's just that the work done by weight is potential energy. So वो potential energy में already include हो जाएगा. It is given that the child comes to rest at z. Alright, use an energy method to find the coefficient of friction between the child and yz, giving your answer as a fraction in its simplest form. Alright, this must be fun. This should be fun. Let's see. अच्छा, अब हम बात कर रहे हैं किसकी? सिर्फ y to z की बात कर रहे हैं. वैसे I shouldn't be this lazy कि मैं that I'm taking a screenshot. I should have just redrawn the whole thing, but anyway, I've done it now. So the child is going from y to z. Okay. And I believe we were given sine alpha. Sine alpha is 0.28. Yeah. So sine alpha is 0.28. Use the identity is sine square plus cos square theta equals to 1 to find out the value of cos alpha. So I'm going to do 1 minus 0.28 squared, take the square root of it. So cos alpha is equals to 0.96. Okay, please don't ask me how I've worked this out. I've simply used this identity. Sine square alpha plus cos square alpha equals to 1. Okay, so just take the square of 0.28, subtract it from 1, take the square root of it, and you get 0.96. Okay, why have I done this? You'll find out shortly. Now, as the child is sliding down, first of all, what will be the change in height? Let's work that out. The change in height will be 2 sine alpha. Okay, so this is alpha, this is 2. The change in height will be 2 sine alpha. ठीक है, 2 sine alpha. Okay. Now what's the weight of the child? 250 Newton. The component of weight which is acting parallel to the plane will be 250 sine alpha. 250 sine alpha. The component of the weight which is acting perpendicular to the plane, that's going to be 250 cos alpha. 250 cos alpha. The normal reaction force will be equal to 250 cos alpha since there is no external force. Okay. And since the child is moving in this direction, actually wait, we have to use the energy method. Yeah, we have to use the energy method. Now bear in mind that the child's velocity at y is what we worked out in the previous part, that's 4 under root 2. And if the child comes to rest at z, that means the final velocity is equals to 0. Okay? Alright, now. Yep, the velocity at y was 4 under root 2. That means the velocity at y now becomes the initial velocity. The velocity at z, since the child comes to rest, is equal to 0. Okay? Okay, what's the energy method? Actually, wait a minute. Let's find out the frictional force before we start with the energy method. So the normal reaction force will be equal to 250 cos alpha. So that means the normal reaction force is equals to 250 into cos alpha, which is 0.96. That's equal to 240 Newton. Which means the frictional force, चलो अभी frictional force को ऐसे ही रखते हैं, ठीक है? We'll come back to it later. Let's write down what it's equal to. It's equal to mu times r, but we'll come back to it later. Okay, now, sir, can you please tell if you have an updated syllabus? Beta, ab ek kaam karo, keep the syllabus in front of you. Whatever topics that you find, you cross them out from the syllabus. Whatever topics you don't, that means I haven't covered those. Okay? Simple as that. Don't be so lazy कि आप हर चीज़ पूछ के करो. Just figure it out. Simple as that. All right. Now, total work done is equals to change in potential energy plus the change in kinetic energy. All right. Total work done means by minus against. All right. Now, is there any form of driving force? No, there isn't. Is there any form of force that is acting in the opposite direction? Yes, there is. Why? Because this is a rough plane, which means there is frictional force. Okay, there is frictional force acting in the opposite direction. Okay, so we need to find out the work done against motion. Okay, now this is equal to the change in potential energy. The change in potential energy is going to be a loss in potential energy. Why? Because the child is sliding down. Okay, and what will be the change in potential energy? That's going to be m into g into h. And what's the change in height? It's 2 sine alpha. So into 2 sine alpha. Plus the change in kinetic energy. What's the change in kinetic energy going to be? It's going to be half into m into v squared minus u squared. That means into 0 squared minus 4 under root 2. Okay, and we kept the exact value, thankfully. So that's basically going to be 32. Okay, when you take the square of 4 under root 2, you get 32. All right. Now, 0 minus against. Achha, ye jo main against likh raha hu, what is this? This is basically the work done by the frictional force. Okay, this against that I'm writing, this is basically work done by any force that's acting in the opposite direction. So this is basically the work done by the frictional force. So 0 minus against is equals to, now let's work this out, 25 into 10 into 2 sine alpha. What's sine alpha? Sine alpha is 0.28. So this is equal to 140 minus 140. Plus, let's see what do we get, 1 upon 2 into 25 into 0 squared minus 32. So you get minus 400. So that means the work done by the against force, by the force that's acting against the direction of motion, is equals to 140 plus 400. And what's that equal to? That's equal to 540. What is this? This is the work done by the frictional force. Now, how do you calculate work done by frictional force? Work done by any force is force into distance. Okay? Work done by any force is force into distance. How can I find out the height? The child slides 2 meters down. So what will be the height? Height is equals to 2 sine alpha using trigonometric ratios. Okay. And this is equal to what? This is equal to 540. This is equal to 540. Now what is the frictional force? We don't know. What is the distance? The distance is 2 and this is equal to 540. That means the frictional force is equals to 540 divided by 2, which is 270. Now what is the frictional force equal to? It's mu times r, which is 270. What is mu? That's exactly what we're here to find out. What is r? R we worked out earlier, that's 240. So mu into 240 is equals to 270, which means mu is equals to 270 divided by 240, and that's equal to 9 upon 8, which is 1.125. I see ya? 9 upon 8, or since this is a terminating decimal, you can write it as 1.125. ठीक है? मज़ा आया? Sir, in against, we work done by, yep, that's correct. Work done by resistive force only. In against, we only take the work done by the resistive force. Okay, I'll look at question number 49 also, don't worry. Okay. Can we make a triangle with opposite side being 7? Yeah, you can do that, but I'm not. इतनी ख्वारी क्यों कर रही हो? जब एक सीधी सादी सी आइडेंटिटी है sin square theta plus cos square theta equals to 1, then just use that. Cos theta will be equal to 1 minus sin square theta and then take the square root of it. That's it. So also, when do we f equals to mu r, the ms gives marks for showing r. If I put r unsimplified in the equation, will I get marks? Yeah, it's okay. If you put r as it is, you will get marks. ठीक है, ज़रूरी नहीं है कि आप r को simplify करें. अक्सर साइड नोट पे लिखा होता है. साइड नोट allows the unsimplified versions also. Okay. All right. Now there was another question, question number 46. I'd like to do some questions with connected particles. Acha, since I'm not, you guys are okay with me streaming momentum tomorrow, and then tomorrow also after momentum doing a full syllabus run through? That's okay with you guys, right? Yes, no? सर आप करते हो तो मज़ा लगता है, मैं करता हूँ. Okay. In MS sometimes it says allow mix-up of sine / cos. No, I can't tell you exactly what it means by that. I need to be able to see the question before I can answer that. अच्छा, एक और कोई connected particles का देखते हैं, connected objects का, जिसमें we have to use the energy method maybe. ये भी कर सकते हैं. अच्छा, ये मोमेंटम भी आ गया यहाँ पे. This question I've solved. Questions like these I've already solved. You're welcome. चलिए ये करते हैं. This looks like a nice question. Yeah. 42 October November. Tell me the question number from this worksheet. If that question is in this worksheet तो ये बताएं. अच्छा वेट, जोहेर आपने एक और सवाल भी बोला था. 42 October November 2023. Okay, let's do that. It better be a work energy power related question. Question number 6. Okay. A railway engine of mass 120,000 kg is towing a coach of mass 60,000 kg up a straight track inclined at an angle of alpha to the horizontal where sine alpha equals to 0.02. Okay. There is a light rigid coupling. अच्छा this question. अच्छा आमना मैं आपका ज़रा कमेंट पिन कर लेता हूँ फिर अभी थोड़ी देर में देखता हूँ. ठीक है. अच्छा this question is from October November 2023 paper 4 variant 2. ठीक है. Now, a railway engine of mass 120,000 is towing a coach of mass 60,000 kg up a straight track, inclined at an angle of alpha to the horizontal where sine alpha equals to 0.02. There is a light rigid coupling parallel to the track connecting the engine and the coach. So coupling is basically what connects the engine and the coach. Okay, instead of a rod, instead of a wire, you have a coupling. The driving force produced by the engine is 125,000 Newton, and there are constant resistances to motion of 22,000 and on the engine and 13,000 on the coach. Find the acceleration of the engine and find the tension in the coupling. Okay, so here we have an inclined plane. Yeah. So this is alpha. Okay, let's make a big circle for the railway engine. Let's make a small circle for the coupling. Sorry, for the coach. So this is the rail and this is the coach. Okay. Now, it's moving up the plane. So make double arrows to show the direction in which they're moving. Acha, what is the driving force? The driving force is 125,000. ठीक हो गया. What about the constant resistances to motion? So there is 22,000 on the engine. So 22,000 here. 22,000 on the engine. And there is 13,000 on the coach. ठीक हो गया. Achha, find the acceleration of the engine and find the tension in the coupling. Okay, so if I'm looking at the rail, so from the rail's perspective, tension is acting away from the rail. From the coach's perspective, tension is also acting away from the coach. Now, what is left? The weight components. So since we don't have to consider friction over here because the resistance to motion is already given to us, that means that includes everything. So this is alpha. This will be equal to 120,000 G sine alpha. Now I'm deliberately writing 120,000 G sine alpha instead of 1,200,000 because that's going to be way too many zeros to deal with. So I'm just going to write 120,000 G sine alpha, which is acting down the plane, considering that this object is moving up the plane. Okay, so let's look at the forces from the rail's perspective. So if I look at the forces from the rail's perspective, this is what we see. We see that the driving force is 125,000, okay, minus 20. I think I'm going to run out of space. Should probably continue over here. How much space do we have? Plenty. Okay, so minus 22,000, okay, plus 120,000 G sine alpha, okay, and then plus the tension also acting in the opposite direction. Did I miss anything? I don't think so. So I've considered the driving force, the weight component acting down the plane, the resistance to motion, and the tension. This is equal to mass times acceleration, which means 120,000 A. ठीक है. अच्छा, अब इसको सिंप्लीफाई हम ज़रूर करेंगे. So 22,000 plus 120,000 times 10 times sine alpha. What is sine alpha? 0.02. Okay, thankfully this will become a nice value now. So here's what I'm looking at. 125,000 सही है, minus 46,000 minus t is equals to 120,000 है. आज से ज़्यादा सवाल तो इसमें ज़ीरो लगाने में ही, आज ज़्यादा टाइम तो इसमें ज़ीरो लगाने में ही निकल जाएगा. अच्छा, let me just do it again. I don't know, when there are too many zeros, I tend to be conscious about the working. So 120,000 into 10 into 0.02, ऐसे है, yeah, plus 22,000, so that's 46,000. Yep, so far so good. So 125,000 minus 46,000, that's equal to 79,000. So 79,000 minus t is equals to 120,000 A. So we have two unknowns, and clearly this is not enough. Now let's look at the forces from the coach's perspective. So coach की story में भी थोड़े से twist हैं. So we do have to consider the weight component of the coach. So this is alpha. The mass of the coach is 60,000. So this will be 60,000 g sine alpha. Okay. So the coach is moving up the plane because of the tension. So tension becomes the forward force minus 13,000 plus 60,000 g sine alpha. Okay, that's it. No other force acting in the opposite direction. Tension, the resistance to motion, the weight component. Okay. And this is equal to mass times acceleration. What is the mass? The mass is 60,000 A. ठीक हो गया? Okay. Now, let's see what's next. So 13,000 plus 60, 1, 2, 3 into 10, एक ज़ीरो और लगा देते हैं, into sine alpha, which is 0.02. Here we go, that's 25,000 plus 13,000, so that's 38,000. So t minus 38,000 is equals to 60,000 A. ठीक है? Okay. So we have one equation, and here's the second equation. Now, इसको ज़रा एक के नीचे एक कर लेते हैं, आसानी हो जाएगी. If I add them up, here's what we get. So we get minus 38,000 plus 78,000, sorry, plus 79,000, which I think will be 38 again. No, wait. Minus 38 plus 79. It's 38 plus 79. That's equal to minus 40, positive 41. Thank God. 41,000 equals to 180,000 A. So 41,000, चलो एक काम करते हैं, हम ज़रा 1000 क्रॉस कर देते हैं. So 41 divided by 180, what's that equal to? That's equal to 41 upon 180. Which is, I think मैंने कुछ गड़बड़ कर दी. गड़बड़ किया मैंने? नहीं, एक सेकंड. Minus 38 plus 79, that's 41,000. 25,000? What's 25,000? T minus 25,000. Acha, let me check. $13,000 plus 60,000 into 10 into 0.02. Oh yeah, you're right. It's T minus 25,000. You're right. I don't know how I got 38,000, but yeah, thank you for pointing that out. Okay, so minus 25 plus 79, that's equal to 54,000, which is equal to 180,000 A. So A is equals to 54 divided by 180, which is equal to 0.3 meter per second square. Okay, check as you go along so that you don't end up making errors like these. Okay, and you won't have time towards the end. So here we go. We have the acceleration, which is 0.3 meters per second, 3 meter per second square. And you also have to find out the tension in the coupling. So let's use any one of the two equations. So let's use T minus 25,000 is equals to 60,000 A. And since we've already worked out the value of A, which is 0.3, let's use this to find out the tension. So 60,000 into 0.3 plus 25,000, what's that equal to? That's equal to 43,000. So we have the tension, that's 43,000. Acha. Now, ये part आसान है, but there's a lot that can go wrong. I mean, this is nothing different from a pulley question, except that you have to consider the weight component also, which in some pulley questions also you have to, by the way. But considering the amount of time that we spent writing zeros, it's easy to miss a zero here and there and get the whole thing wrong. Okay, now let's have a look at part B. Part B says, yeah, P3 inshallah I will start after क्या? After M1. अच्छा, so एक सेकंड मैं ज़रा अपनी अगली जो M1 की स्ट्रीम है ना उसको ज़रा टाइम चेंज कर दूँ उसका. So I hope you guys are okay with doing momentum tomorrow. Considering Sir Zain is already doing momentum today, it makes no sense. Okay, I do momentum today also. I'll do it tomorrow. So just give me a minute. Let me reschedule it. Tomorrow, what time tomorrow? Chalo, I'll figure it out. Abhi, I'll just make it 2 p.m. Okay, now. At an instant, when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta to the horizontal. The power produced by the engine now is 4,500,000, and as a result the engine maintains a constant speed. All right, that's nice. Assuming that the resistance forces remain unchanged, find the value of P. All right, so अब सीन ये है कि now it's on a different part of a track where the angle is beta, ठीक है, and everything else is constant except that there is no acceleration, ठीक है. बस इतना मुश्किल नहीं है, ठीक है, इतना मुश्किल नहीं है. We can use the previous scenario. Yeah, we can use the previous two equations, ठीक है. ख़ास तौर पे we can use this one, ठीक है. हमें एंगल चेंज कर देंगे, हम एंगल को बीटा कर देंगे, ठीक है, and we will make acceleration equals to 0. Okay, and we can also use this one. Okay, now, so it's still moving up the plane, okay, except that acceleration is equals to 0. Constant speed means acceleration is equals to 0, okay, and the driving force will be different. Okay, so the driving force will be different. So yeah. So how do we find out the driving force? Power is equals to force into velocity. The power is 4,500,000 equals to force times velocity, which is 30. Chalo shukar hai, 1 0 to kam hoga. So 4.5 into 10 power 6 divided by 30, that's equal to 150,000. So the driving force is now 150,000. Okay, so the force that due to which it's going up, not accelerating, due to which it's going up is 150,000. Okay, so that means now if I look at the forces from the rails perspective, it's going to be 150,000. Okay, and since the resistance forces remain unchanged, so minus the resistive force, okay, plus the weight component added, except that this time it's not going to be sine alpha, this time it's going to be sine beta. ठीक है. अच्छा, it says pulley, अब मैं उसको ठीक कर दूँगा. So it should now say not sine alpha, it should say sine beta. And it should not be equal to mass times acceleration, it should simply be equal to 0. Okay, so before we deal with the coach, let's first deal with the rail. Let's simplify this. Okay, so here's what we're looking at. We are looking at 150,000 minus 22,000. So this becomes 128,000. अच्छा, इसको भी ना 1,200,000 लिख लेते हैं because I'm afraid I will forget multiplying it by 10. Sine beta minus t equals to 0. Okay, now then let's talk about the coach. Okay, so as far as the coach is concerned, there is tension due to which it's going up. Okay, the force that's acting in the opposite direction is its own weight. Okay, and the resistance to motion, and here it is. And the other difference to keep in mind is that this is equal to 0. Okay, now let's simplify this. So we have T minus 13,000 minus 600,000 sine beta equals to 0. So this is our first equation, and now we have our second equation. Now let's write both these equations under each other, and then let's use elimination to solve them. ठीक है? So जैसे मैं इन दो equations को add करता हूँ, what happens is T gets eliminated not by coincidence but by design. Minus 13,000 plus 128,000, so that's equal to 115,000. ठीक हो गया? Minus 600,000 minus 1,200,000. Ya Allah khair. Minus 1.2 into 10 power 6 minus 600,000. 1, 2, 3. That's equal to minus 1.8 million. So minus 1,800,000 sine beta equals to 0. ठीक है? So we're looking at 115,000 equals to, अब थोड़ा लेजी हो जाते हैं ज़रा, इसको इसके इक्वल कर देते हैं. ठीक है? Which means that I can cross out these 3 zeros and I can cross out these 3 zeros. ठीक है? Now what's next is the following. 115 divided by 1800 sine beta is equals to 115 divided by 1800. So 115 divided by 1800, let's take sine inverse of the answer, and we get beta to be equal to 3.66 degrees. Please tell me. Acha वैसे, since it's angle, we will give the final answer correct to 1 decimal place. So beta is equals to 3.7 degrees. Please tell me that is the correct answer. Acha guys, just give me 1 minute. Okay, क्या status है? Summary please. Okay, I'll give you guys a summary. देखो, what's happened in this part is this. In this part, the power is different, okay, and the constant speed at which the rail is traveling is 30 meters per second, which means that the driving force can be worked out by using the formula of power equals to force into velocity, and the driving force is equals to 150,000. ठीक है? Now, if I look at the forces from the rail's perspective, so notice that the rail is moving up with a force of 150,000 minus all the resistive forces, one of which is mentioned in the previous part, minus its own weight component, except this time the weight component will be 125,000 sine beta. अच्छा, I know background में थोड़ी सी noise है, अभी सही हो जाएगी. There's some work going on. Okay, I'll just lower the volume for a while. ठीक है? नहीं blender नहीं चल रहा. There's some renovation work going on. अच्छा, and then plus T because tension is acting in the opposite direction as far as the rail is concerned. Okay, so the only difference is that it's moving at a constant speed, so acceleration will be equal to 0. The driving force is different, and the weight component is different. Why? Because of sine beta. ठीक है, अच्छा ज़्यादा कम हो गई. चलें, अब सही है. Okay, now then we look at it from the perspective of the coach. If I look at it from the perspective of the coach, it's going to be T, since T is the force that's acting up the plane, minus the resistance to motion, same as the previous part, minus its own weight component, which will now be 60,000 sine beta. Okay? And that's equal to 0. Why? Because it's moving at a constant speed. After that, I mean, it's simple, but you still have to do a lot of simplification, but it's all algebra after that. आमना बेटा डोंट यूज़ लॉग्स. ठीक है, आप कोई तीर नहीं मारोगी लॉग्स यूज़ करके. एग्जामिनर कोई आपको सेपरेटली बुला के शाबाशी नहीं देगा. दोज क्वेश्चंस आर डिज़ाइन टू बी डन यूजिंग ट्रायल एंड एरर ओनली. ठीक है. Why is it coming in negative? Do I remove the negative sign? Maybe you're making a calculation error here. Maybe you're not considering the forward force as the correct one. Maybe you're mixing them up or something like that. Where did 22,000 come from? ये तो मैं नहीं बता सकता. I'm afraid I can't answer that question. Sir, kind of unrelated, but when sketching cubic graph in IGCSE, ये IGCSE वाले लोग यहाँ पे क्या कर रहे हैं? Do we need to show the turning points? No. In cubic graphs, you don't need to show the turning point. You just need to make sure that the turning point is in the correct place as per the x-intercepts. Sir, do annotations on the question diagrams count as working? If you want, draw them separately. ठीक है, उसको separately कर लो. अच्छा, just give me 1 minute, guys. Asha, do this question. This question involves energy method, and you have a car that is towing a trailer. So you have connected particles plus energy method. Solve this question. I will be back on my desk in a few minutes. Okay. No, I don't teach physics. Now, let's see what is next. सर कोई 8-10 मार्क्स वाला करवा लें? बेटा ये भी 10 मार्क्स ही है टोटल. ठीक है, so there you go. So let's solve this. This is question number 43 from the PDF. This is February-March 2024, paper 4 variant 2. ठीक है, and question number 43 of this worksheet. Let's see what it says. A car of mass 1800 kg is towing a trailer of mass 300 kg up a straight horizontal road, inclined at an angle of alpha to the horizontal where sine alpha equals to 0.05. The car and the trailer are connected by a tow bar which is light and rigid and is parallel to the road. There is a resistance force of 800 Newton acting on the car and a resistance force of F Newton acting on the trailer. The driving force of the car's engine is 3000 Newton. It is given that F equals to 100. Find the acceleration of the car and tension in the tow bar. Okay, so first of all, realize that it's an inclined plane. This is alpha. Here is the car. ठीक है, and here is the trailer. इनको हम connect कर देते हैं with the tow bar. Okay, so this is the car, this is the trailer. Now first of all, let's resolve the forces. So are they moving up the plane, inclined at an angle? Yeah. So this is alpha. Now the weight component will be 18,000 sine alpha. ठीक है, weight component is 18,000 sine alpha. collision वाले कल करवाऊंगा guys. ठीक है, वो मुझे आज मोमेंटम में करवाना था लेकिन आज इसी को टाइम देते हैं. collision वाले कल करेंगे इंशाल्लाह. ठीक है, so tension acting in this direction. ठीक है, the driving force of the car is 3000, so there is 3000 Newton force acting in this direction. Okay, and there is a resistance to motion on the car of 800 newtons, and there is a resistance force acting on the trailer of 100 newton. Okay, नहीं मोमेंटम की स्ट्रीम हम कल रखेंगे. ठीक है, कल मोमेंटम भी रखेंगे और सिलेबस रन थ्रू भी रख लेंगे. सो ऑल्दो आई एम पर्सनली नॉट इन फेवर कि मैं एक दिन पहले कुछ कराऊं, बट आई वुड रादर compromise on quality than I would rather compromise on quantity than quality. ठीक है, उल्टा बोलने लगा था. Okay, so the trailer's weight component will be 3000 sine alpha. ठीक है, and the tension on the trailer is acting in the opposite direction. ठीक है. On Instagram, I announce about my streams on Instagram and YouTube post also. Okay, now let's look at the forces from the car's perspective. So from the car's perspective, there is 3000 Newton force acting up the plane minus the resistance to motion, which is 800, plus 18,000 sine alpha, something we'll figure out shortly. Any other force? Oh, tension bhi to hai. Plus the T, which is equal to mass times acceleration, which means 1800 A. Okay, now let's simplify this. So you have 800 plus 18,000 actually, into sine alpha, which is 0.05. So that's 1700. This means that this is now 3000 minus 1700 minus T, which is equal to 1800A. अच्छा, अब इसको simplify कर लेते हैं. So 3000 minus 1700, that's equal to 1300. So we have 1300 minus T, which is equal to 1800A. Now that's one equation. बेटा IGCSE की मैं syllabus recap नहीं करा रहा. I streamed some topics that are expected in tomorrow's paper. Okay, you can watch the previous run through if you want a recap. ठीक है. Now this is your first equation. Let's park it on the side. We'll come back to it. Okay, let's just double check, make sure that we've done everything correctly, and let's park it on the side and then we'll come back to it. 800, 18,000 into sine alpha, which means 0.05, that's 900. So 800 plus 900 is 1700, 3000 minus 1700. Yep, sounds good. ठीक है, अभी भी कोई गलती है तो बता दो, but I think it's fine. Now let's look at the trailer. So from the trailer's perspective, it's the tension which is acting in the direction of motion, minus 100 minus 3000 sine alpha. ठीक है, इसमें मैंने ब्रैकेट बना के प्लस नहीं किया, इसमें गलती हो जाती है, equals to 300 mass times acceleration, which means equals to 300a. So 100 minus 100 minus 3000 sine alpha, which is 0.05, we get 250, which means the other equation that we're looking at is t minus 250 is equals to 300a. Now let's write down the previous equation directly under the second one. So this is what we get. Tension gets eliminated, not by coincidence, but by design. Minus 250 plus 1300, that's equal to 1050, is equals to 2100a. So 1050 divided by 2100, that's equal to 0.5. So the acceleration is equals to 0.5 meter per second square. ठीक हो गया? Okay, now collision से related questions हम कल करेंगे, ठीक है? So momentum stream, inshallah, I will do it tomorrow. So is it okay that I use mode 5.1 in these type of questions? Basically not doing the calculation steps. What do you mean mode 5.1? You mean you solve, you mean you solve simultaneous equations in your calculator? No, it's not okay. You have to show the working, okay? All right, now that we have the acceleration, let's find out the tension. So let's use t minus 250 is equals to 300a, which means t minus 250 is equals to 300 into 0.5, which is 150. That means t is equals to 150 plus 250, that's equal to 200. 200 plus 200, that's 400 Newton. There we go. Achha, we'll have a poll. Okay, we'll have a poll as to whether I should do it today or tomorrow. Okay? Then you guys can give your input and we will decide according to that. Okay, now it is given instead that the total work done against F in moving a distance of 50 meters up the road is 6,000 joules. The speed of the car at the start of 50 meter is 20 meters per second. Use an energy method to find the speed of the car at the end of the 50 meters. Okay, now reason why I'm solving this question is for two reasons. One is that you have to use the energy method, obviously. The other reason is that this is the first question that we're doing where we have to use the energy method where two particles are connected. Okay, other than the pulley related questions, this is basically the first of its kind where two particles are connected. Okay, okay, now. So considering that the car moves 50 meters up, let's find out the change in height. Okay, so this is alpha. So the height that it gains will be 50 sine alpha. Okay, so the height is equals to 50 sine alpha. And एक काम करते हैं, इसको निकाल ही लेते हैं. Don't want to deal with sine alpha again and again. So 50 into 0.05, that's equal to 2.5. So that means the height is 2.5. Okay, now how much space do we have? Plenty of space. Okay, so what is the energy method? The energy method is total work done equals to change in potential energy plus change in kinetic energy plus the change in kinetic energy. Okay, now what's the driving force? So are we given the driving force? Okay, so the driving force is constant. That means it's the same one that we can apply in part A and we can apply it in part B also. Okay, so when we are using the total work done energy method, total work done basically means by minus against. Okay, now what about, are we going to consider the work done by tension? Yes or no? Are we going to consider work done by tension? Yes or no? Yes or no? This is 800. Yeah, 800. Work, the driving force is 3000. Okay. No, we're not going to consider the work done by tension. Why not? Why are we not going to consider the work done by tension? Because it will cancel out. मैंने यही सवाल पूछा ना, how come everyone is saying yes? We're not going to consider the work done by tension because it will cancel out. देखो ना, if I consider the work done by tension from the car, ठीक है, if I look at the car's perspective and if I look at the work done by tension, for car it will be a force that's acting in the opposite direction. So we will subtract. For the trailer, it will be a force that's acting in the same direction. So it will cancel out. Okay, so that's the reason. Did we ever consider work done by tension? We did so many questions yesterday. Did we consider work done by tension? We didn't. Okay. Isn't a resistive force as well? Doesn't matter whether it's a resistive force or driving force. It's basically acting in the direction of the coach, and it's acting in the opposite, in the direction the coach is moving, and it's acting in the opposite direction. What's the other? Train hai kya hai? Car. Yeah. No, wait. There's a car and trailer. So this is the trailer, and this is the car. So for the car, it's acting in the opposite direction of motion. For the trailer, it's acting in the direction of motion. Even if you do consider it, it will still cancel out. Okay, even if you do consider it, it will still cancel out. Okay? So by minus against is equals to change in potential energy, and it will be a gain in potential energy. And as far as kinetic energy is concerned, it will also be a gain in. Let's not write that. It will be. We'll find out whether it's gain or loss. Okay. Now, what is the work done by the driving force? That's basically the force produced by the engine, which is 3,000. Multiplied by the distance, that will give us the work done by the driving force. And what's the distance? The distance is 50. Now, what is the work done against resistance? If we talk about the car, for the car, it's going to be 800 multiplied by 50. Okay, so this is for the car. And then for the trailer, it is given instead that the total work done against F. Now, F was basically the force that was acting on the trailer. Okay, F was basically the force that was acting on the trailer. And what's the work done by this force? The work done by this force is 6,000. So we subtract this. Okay, so I repeat. This is the work done by the driving force, and this is all the work done against the motion. Okay, or work done by all the resistive forces. Okay. What's the driving force? 3,000 multiplied by 50. What about the car? There was a constant resistance to motion on the car of 800, which means 800 times 50 is the work done by this force. What about the work done by this F Newton force that's given to us in the question? That's 6,000. Why are we subtracting? Because these are all the forces that are acting in the opposite direction. Okay. Now, this is equal to change in potential energy. Now, in order to calculate the change in potential energy, we can combine the two objects instead of doing them separately, because they're both moving together, right? It's not like there's a pulley in between where one particle is going down, the other is going up. Both of these particles together as a system are gaining a height of 2.5 meters. So we don't have to do it separately. We can just combine them. Okay, so as far as the change in potential energy is concerned, we can take their combined mass, which is equal to 1800 plus 300, that's 2100. 2100, yeah, no? Yeah, 1000. Yeah, 2100 into G into the height, which is 2.5. Okay, now this will be a gain. Why? Because the height is increasing. Plus the change in potential energy. Now, what will be the change in potential energy? Once again, because they're connected, that means whatever speed one object is moving at, the other object will also move at the same speed. So what was the initial velocity? The initial velocity is 20. Okay, and we have to find out the final velocity. So that means v squared minus 20 squared. There we go. Okay, so once again, I'll summarize. What is the work done by the driving force? That's force into distance. 3,000, what's the distance that they move? 50 meters, so 3,000 into 50. What is the work done against the direction of motion? That means all the forces that are acting against the direction of motion, we will take those and we will multiply that force by the distance. So as far as the resistance to motion acting on the car, this force, 800 Newton force, we multiply this by 50. And as far as the F Newton force is concerned, which was acting on the trailer, the work done by that force is 6,000, or the work done against that force is 6,000. Okay? Now, let's work this out. 3,000 into 50 minus 800 into 50 minus 6,000. So we get 104,000. So this is equal to 104,000. So if I just put values in the quadratic formula and then use, yeah, that's okay. No, you don't need to simplify it. So 2100 into 10 into 2.5, what's that equal to? That's equal to 52,500. Okay, let me just double check. 2100 and 10, 2.5 plus 2100 upon 2. So 2100 divided by 2, that's equal to 1050 into v squared minus 20 squared. And while we're at it, might as well write 20 squared as 400. Okay. Now, step by step, let's make v the subject. So first thing we're going to do is we're going to do 104,000 minus 52,500. Okay. And that's equal to 51,500 is equals to 1050 into v square minus 400. Okay, so 51,500 divided by 1050, that is, so I'm looking at a certain value. ठीक है. अच्छा, इसमें हम 400 ऐड करते हैं, then let's take the square root of it. So here's what we get. 51,500 divided by 1050 plus 400 is equals to v square. Now, when you take the square root of v, you get 21.1907, which means, correct to three significant figures, the answer is 21.1 meters per second. That's it. Now, I mean, that's not it. That's a lot of it. But yeah, the value of sine theta was given. Okay, so this is the car. This is the trailer. Okay, this is the change in PE, which is combined. Okay, why? Because the change in height for both of them is the same. It's not like there's a pulley in between. Yeah, sorry, 21.2. Sorry, my bad. It's not like there's a pulley in between and one object is going down, the other is going up. That's not the case over here. They're both connected. They're both moving up the hill. That's why we can calculate the change in potential energy by combining the masses. And then as far as KE is concerned, that is something that we combine either way. ठीक है, मज़ा आया? Did someone ask this? No, I think this is a question that I decided to solve myself, and I hope you guys can see why I decided to solve this question, why I wanted to solve this question. Acha, we have time. Let's have a look at... Okay, let's do a slightly toned down version of the energy method. Let's use this one. Let's solve this question. Momentum tomorrow, inshallah. Okay, momentum tomorrow. Can you check the... Oh, yeah, let me check that. मैंने पिन भी किया था आपका comment. Winter 2242. अच्छा, कौन है? Amna. Amna, can you also tell me the question number? Okay, this basically means that if your answer is in terms of sine and cos, it's allowed. That's what it means. That means, like for example, you can see the equation is a mixture of sine and cos, and that's allowed. That's what it means. ठीक है यार, ये क्वेश्चंस मुझे तो मज़ा आता है सॉल्व करने में यार. ठीक है, कल वो हम इंशाल्लाह मोमेंटम के वो मल्टी स्टेज क्वेश्चंस करेंगे, सो देयर इवन मोर फन. ठीक है. Okay, so this is a slightly toned down version of the energy method, and I think we'll do this question and maybe one more, and then we can end it. Now, the question does not say that you have to use the energy method, but let's use it anyway. Okay. So, a block of mass 10 kg is at rest on a rough plane inclined at an angle of 30 degrees to the horizontal. I think I do have videos where I've explained momentum. A force of 120 Newton is applied to the block at an angle of 20 degrees above a line of greater slope. There is a force resisting the motion of the block, and 200 joules of work is done against this force when the block has moved a distance of 5 meters up the plane from rest. Now, if it is moving 500 meters up the plane, then my question is, what will be the change in height? We all can work that out. So if it moves 5 meters and this is 30 degrees, that means the increase in height will be 5 sine 30. And sine 30 is half, so that means it gains a height of 2.5 meters. Okay, now. Ab remember, in order to calculate the work done by the driving force, abhi kya ban jayega? This will be a driving force for this object. Okay, this is the force that's driving this object up. Okay, this is an external force. So the question is, what will be the force that is taking this object up? That is not the 120 Newton force. That is the component, the horizontal component of the 120 Newton force. So the force due to which this object is going to go up the plane will be this force. Okay, and this will be 120 cos 20. So 120 cos 20. Sorry, not, yeah, 120 cos 20. Okay. Achha. Now, what is the energy method? The energy method is total work done is equals to change in potential energy plus the change in kinetic energy. Now, as far as the change in potential energy is concerned, this is going to be a gain in kinetic energy. Total work done means by minus against. Now, what is the work done by the driving force? The work done by the driving force is 120 cos 20. This is the force multiplied by the distance, which is 5, since this is the distance that it moves up the plane. Okay. Minus the work done against motion, which is already given to us, and that's 200. Okay, so you don't have to calculate friction. You don't have to calculate the normal reaction force. It's already given to us, and that's it. It's 200 joules. Okay. And this is equal to the change in potential energy. What will be the change in potential energy? The mass of the object is 10. Acceleration due to gravity is also 10. And the change in height, we just worked it out, that's 2.5. And then what is the change in kinetic energy? So this object started from rest. So half into the mass, which is 10. And since the object started from rest, that means the initial velocity is 0. What about the final velocity? That's exactly what we're here to find out. So v squared minus 0 squared. That's it. How do you know that energy method would work in this question? Because you are given the speed at the start, you're supposed to find out the speed at the end. Okay. Now, you can also use Newton's second law. There's no harm in using Newton's second law. Also, another reason why I have used this energy method is because we're given the work done against the resistive force. That's why I use the energy method. Okay. Yeah, the total work done formula is applicable everywhere. Okay, and it's a game changer given that you really embrace that formula. So here's what I'm looking at. I'm looking at 363.8155. Okay, not rounding off because it's not the final answer. Equals 10 into 10 into 2.5. That's equal to 250. Plus 10 upon 2 is 5, so 5v squared. Okay. So 363.8155 minus 250 divided by 5, take the square root of it. So v square is equals to 363.8155 minus 250 divided by 5, and then do not forget to take the square root of it. When you do, you get 4.771, which correct to 3 significant figures will simply be 4.77 meters per second. There we go. Okay, am I still doing more? Yallah. 44. Let me see what 44 is. चलें 44 इज़ द लास्ट क्वेश्चन. ठीक है, 44 के बाद हम एंड करते हैं. ठीक है. When did you see my?
हमें टाइम नहीं है.
अच्छा अच्छा ठीक है. मोमेंटम मैं कल करूँगा. मोमेंटम टुमारो इंशाल्लाह. Okay, question number 44. A cyclist is traveling along a straight horizontal road. The total mass of the cyclist and her bicycle is 80 kg, right? There is a constant. Please what? Okay. Okay, now, a cyclist is traveling along a straight horizontal road. The total mass of the cyclist and her bicycle is 80. There is a constant resistance force of magnitude 32 Newton to the cyclist's motion at an instant when she is traveling at 7 meters per second. Her acceleration is 0.1 meter per second. Find the power output of the cyclist. Okay. Momentum beta, momentum कल करेंगे. ठीक है. The thing is, I did not want to compromise on work, energy, power. You guys can see the kind of variety of questions that we have. That's why I did not want to compromise on that. So power equals to force into velocity. Although, again, having said that, I'm not in favor of streaming a topic a day before the exam, but we don't really have an option. That is why. So where were we? Yeah, power. Power equals to force into velocity. What is the force? Are we given the force? No, we're not, but we are given. Achha, wait a minute. So, the road is horizontal. Okay. She is traveling at 7 meters per second. And is she accelerating? Yeah, she is accelerating. Okay, so there's got to be a driving force. Okay, there's got to be a resistive force, which is given to us, and that's 32. Okay, so this means that driving force minus the resistive force equals to mass times acceleration. What is the driving force? The driving force is what we are here to find out. What is the resistive force? That's given to us. That's 32 equals to mass times acceleration. Mass is 80, acceleration is 0.1, which means the driving force is equals to 40 if I'm not wrong. Yeah. 18 to 0.1 is 8, 8 plus 32 is 40. And what is the power? Power equals to force into velocity. So the power is equals to 40 times 7, which is equal to 280 watts. There we go. Okay. Power output means just the power. That's it. Okay. Okay, now. Yes, it's a good idea to draw a diagram using a pencil. Part B. Find the steady speed that the cyclist can maintain if her power output and the resistance force are both unchanged. So if the power output and the resistance force are both unchanged, that means what's the power? The power is 280. Okay. And the question is, in order to maintain a steady speed, the driving force must be equal to the resistive force. Okay, steady speed means that the acceleration is equals to 0. Achha. Now the question is, if the power is 280, what is the driving force? We don't know. The driving force will be equal to 280 upon V. So this is 280 upon V. Now what about the resistive force? The resistive force is the one that's given in the question. That's 32. So this means that 280 upon... So why am I using this power? You guys may be wondering, why am I using the power found in the previous part? Because the question says that the power remains unchanged. Okay. So 280 upon V minus 32 equals to 0. It's a 2-mark question, so just straight away solve for the value of V. So that's 280 divided by 32. That's equal to 8.75 meters per second. Okay, now the final part. The final part of the final question of the third last stream. Okay. let's see what it says. The cyclist later descends a straight hill of 32.2 meters. Okay, so the word descend is very important. Make sure to underline it. The length of the hill is also important at an angle of sine inverse of 1 upon 20 to the horizontal. Her power output is now 120 and the resistance force now has a variable magnitude such that the work done against this force. So work done is given. That means maybe it's pointing towards the energy method. The time taken to descend the hill is 4 seconds. Given that the speed of the cyclist at the top of the hill is 7.5, find the speed at the bottom of the hill. Okay, so before we do anything, first let's find out the change in height and let's just make a rough sketch. So here is the cyclist at the top of the hill and here she is at the bottom of the hill. Now at the top of the hill, what is her velocity? That's 7.5. And we're supposed to find out the velocity at the bottom of the hill. Achha. Secondly, what is theta equal to? Theta is equals to sine inverse of 1 upon 20. Okay. Yeah, tomorrow I will do a full syllabus run through alongside momentum. Okay. Why did we equate to 0? Because acceleration is equals to 0. So sine theta and why is acceleration equals to 0? Because steady speed means acceleration equals to 0. So sine theta is equals to 1 upon 20, something that will come in handy. And while we're at it, let's calculate the change in height. So this is theta and the distance, the length of the hill is 32.2, which means the change in height will be 32.2 sine theta. And since sine theta is 1 upon 20, that means 32.2 divided by 20, which is equal to 1.61 meters. Okay. Now, Achha. So what's the energy method? The energy method is total work done equals to change in potential energy, which by the way will be a loss since it's going down the hill, plus change in kinetic energy. We don't know whether it's a gain or loss. We just need to use the change in kinetic energy to find out the speed at the bottom of the hill. Okay. Now, total work done basically means by minus against. That's what it means by total work done. Now, what is the work done by the driving force? Now, notice that we're given the power and it says that the resistance force now has a variable magnitude such that the work done against the resistance force is 1128. But the question is, what about the driving force? What's the work done by the driving force? How do we figure that out? So, in order to find out the work done by the driving force, notice that what are we given? We are given the power. We're given the power output. Okay? What's the power output? The power output is 120. So power is equals to work done upon time. And what will this be the work done by? This will be the work done by the driving force. So the power is 120, which is equal to the work done by the driving force upon the time, which is 4 seconds, cross multiply. So you have the work done by the driving force, which is equal to 480 joules. Okay? Now we've collected all the ingredients. Now it's time to put it all together. Okay? So by means work done by the driving force, that's 480. Against means work done against resistance to motion or against any resistive force, that is 1128, already given in the question. This is equal to a loss in potential energy. Why? Because it loses height. What is the mass of the cyclist? 80 if I'm not wrong. 80 tha na? Huh. 80 into 10 into the change in height, which is 1.61. We'll come back to it in a second. Plus the change in kinetic energy, which means half into 80 into v square minus u square. V square minus u square means v square minus 7.5 squared. Okay? Okay, now let's see what we get. So 480 minus 1128, that's equal to minus 648. Which is equal to 80 times 10 into 1.61, that is minus 1288. Okay. Plus 40, 80 upon 2 is 40, v square minus 7.5 squared, that's equal to 56.25. So keep everything as it is till you get to the very end. Now, minus 648 plus 1288, that's equal to 640. Haath ke haath 40 se bhi divide kar lo, that's 16. So that means v square minus 56.25 is equals to 16. So that means v square is equals to 16 plus 56.25. That's equal to 72.25. Now the moment of truth. Let's take the square root of it and see what we get and see whether that is the correct answer or not. Wow, we get an exact value. That is reassuring. So v is equals to 8.5 meters per second. Now I don't know who asked this, but I hope this is the correct answer. And that's it. We are done with work energy power. I've solved as many questions as I could. That's why we did not do a momentum stream, and we're not going to do a momentum stream tonight. We will inshallah do a momentum stream tomorrow. So tomorrow you guys have an exam. It's an AM exam, I believe, and you guys get done early, right? So I'll see if I can keep the stream early for momentum. Then we will have another syllabus run through later in the day. Okay? So that's it, fellas, I guess. जी बोलें Zuhair, what's your one last confusion? PM exam. What time do you guys get done with the exam? Let me know. Could you explain the most efficient way to attempt the paper? But I got to be honest, how to attempt the paper and all that stuff, I noticed Sir Zain has plenty of content on it, and I think he's done a very good job. So it's best you watch his video to find out how to attempt the paper. But to keep it simple, I will always say attempt the simpler questions first. Okay, like for example, coplanar forces, anything where you don't have to think a lot. Okay, attempt those questions first. But for fine details, you can check out his video. Sergi, when will O-level syllabus run through happen, or will it even happen? No, I'm not doing an O-level syllabus run through. I did a poll yesterday. You guys said you do not want a syllabus run through. Rather, you wanted me to cover the topics that haven't been tested yet. So that's exactly what I did. So tomorrow for M1 students, I will be doing a momentum stream. Then tomorrow only, inshallah, I will do a syllabus run through. Ab syllabus run through itna detailed nahi hoga. Just keep that in mind. Okay? Because I think I've covered everything in detail. There's nothing left now. So yeah, that's it. Okay? I will see you guys inshallah tomorrow. So take care, fellas. Allah Hafiz. Acha, mujhe jaate jaate ye bata de, what time do you guys get done with the exam? You guys still haven't answered that question. What time do you guys get done with the exam? Please tell me. Tomorrow. When do I multiply the distance with? Whenever you want to find out the work done. For work done by any force, it's force into distance here. किसी भी force का work done निकालना हो, external force का, it's force into distance. ठीक है? That is when you multiply it by distance. 4:15, 4 p.m. Ooh, that is bad. 5 p.m. Oh crap. तो बेटा, और पेपर कौन सा है? AM वाला है, PM वाला है? Is the paper AM or PM? अच्छा, M1 का पेपर क्या है? AM है, PM है? ओके चलो M1 का अगर PM है तो हम थोड़ा लेट नाइट पुश कर सकते हैं सिलेबस रन थ्रू. ठीक है, चलें. सो आई अपडेट यू गाइज ऑन माई इंस्टाग्राम. ठीक है, वट एवर आई अनाउंस ऑन माई इंस्टाग्राम. ठीक है, सो आई स्टॉप हियर फॉर नाउ. सी यू गाइज इंशाल्लाह इन द नेक्स्ट स्ट्रीम. सो टेक केयर फेलर्स. अल्लाह हाफिज़.